clear quartz is just higher purity from higher temperatures or...
Hey y'all, let me know if you've got signal, video, audio, etc, etc. Give me a status check, let me know how things are going, because we are testing a location today. We are checking to see if we'll be able to do a rocking, I don't even know what the rocking stream. A stream about rocks. Yes, rocks, Max McSwing, you got it. What I need to know from y'all is, can you hear me okay? Can you see the camera? Is it alright? Video's good, audio's good. That's a weird, like, disconfigured hand just in the, I guess it's selling rings. Let me know how things are going. The Inuki 5x5, 5x5 AOS, excellent, excellent, excellent. So I'm here, I mean, y'all know me, I'm behind the camera today, I'm running it myself. I got Twitch chat on my arm, or on my phone right now. And we are here with a couple of geologists who I will introduce in just a bit. Up in the northern part of North Carolina. It's actually a place called Emerald Hollow Mine. And we are checking out some rocks here in their little, I'm going to say rock shop, but it's not actually just a rock shop. It's, I can't pronounce it, I'm going to make them pronounce it. It's a place where you cut rocks and gemstones into things that make them look better. I'm not a geologist, whatever. That's why I'm behind the camera today. This field trip rocks. Thank you, there are going to be so many, the video and audio are rock solid. I don't know if I can deal with all these puns, people. Really? Rock solid, thank you. But we're going to be talking with a couple of geologists. One of them is actually a Twitch streamer who streams geology. Y'all saw her in the stream quite often. Rocket Sage is here with us. And then we've also got the geologist who's sort of on duty here at Emerald Hollow. His name is Drew. So in just a second, they're finishing up some other stuff right now. And we will be talking with them about rocks, specifically what types of rocks can be found here at the mine, how you look for rocks, how they cut rocks. I don't even know. Like, once again, I don't know everything about rocks, but I like to surround myself with people who are smarter than me. So today I'll be surrounding myself with people who are smarter than me concerning rocks, so we can learn some stuff. Now we stream rocks and rocket. That's hilarious. Rocks and rockets. Nice. One more thing, y'all. This is going to be a stream. There is very little cellular signal here. We're actually connected to their Wi-Fi, so please do expect some frame drops and stuff like that, just because we only have a single connection. As I move around and stuff like that, I may very well end up in some positions where the Wi-Fi is not fantastic, so just be advised that we don't have the normal multi-stream connection like we normally do. It's going to be a little bit hitchy sometimes, but feel free to tell me. Not going to be too terribly much that I can do about it. Now, I'm going to try a new thing right quick. Hang on a second. Let's do this. Yes, rockets, rocks, and bees. The bees are the ones that don't fit in. So, hang on a second, chat. Yes, alright, that's fantastic. Can I flip this around? I can flip this around. And can I do this? Just to prove that I am actually here? Yeah, I am actually here right now. Standing over on the side of the rock shop. Rocket Sage is over here too. Do you want to like scoot this way? Yeah, look. Rocket Sage is here too, y'all. The lighting back here, there's like, lights.
Yeah, lights everywhere. Don't drop it, don't drop
it! Anyways, y'all, like I said, shop, they've actually got some customers there right now, and when they're done there, we're gonna flip over and talk about rocks. You can start talking about rocks right now.
I mean, look at all these, first of all.
I mean, tell me what to look at.
Okay, so these are probably some of my favorites right here, just because I love emerald.
Yeah, go for it.
But this here,
oh my gosh,
is, I think, hydrothermally altered. Now, hydrothermal alteration is something that people that work in mines have to deal with. It's not something I did in grad school, but it's something that fascinates me. And this is just a giant chunk of emerald, which is...
Wait, that's an emerald?
Yeah, this is a emerald, all of this is emerald.
Really?
Yeah.
That's crazy.
Yeah.
It's just the difference between it's not cut or finished up or anything like that yet.
It's just a raw piece of emerald.
No
you can
kidding.
see another one here. I mean, there's all over. This one looks maybe like it could be an aquamarine, because aquamarines, morganite, and emerald all come from the same mineral called beryl.
Okay.
As well as some others that I just can't remember off the top of my head.
Gotcha.
But I think these are just fantastic. I personally like them raw. I don't like them cut, because
really?
I can't then identify them anymore.
It's not, it's like, oh, that's nice. It belongs in a museum or something.
Yeah,
like,
I'm a
really?
geologist, not a gemologist. So once they're cut, it's beyond me. I don't know how to identify it anymore. But
Well, so let's do this. Let's go ahead and start off. You're an actual geologist. Like you studied it officially. You're not like me. I just really like rockets. I'm not a rocket scientist. You actually studied that. You like went to college for it. Like what did you do?
So I did my master's, and that's where I ended. But I did teach at Cal State for 2 years after that, and then at a university in West Virginia for about a year and a half. And now I'm headed back west for another job.
Gotcha.
So geology takes you a lot of places. And that's probably one of the reasons that it's one of my favorite things in the world to do. That, and I just love being able to see landscapes and know how they were formed.
Yeah.
And understanding that, oh yeah, this is, I don't know, some millions and hundreds of millions years old is pretty phenomenal to me.
Is it so? When you study rocks, what do you just look at lots of rocks? Like, how do you study rocks?
Sometimes.
I actually don't even know how one would study a rock.
So you kind of go into like an overview in Geology 100 of how the Earth is and why it is, and just kind of like the basics of everything. But when you get into the rocks, you take a couple different courses. You take mineralogy and petrology. And in those two classes, you look at just minerals, but you also then look at rocks, and then you look at both of those things under what's called a petrographic microscope. And then we show you basically how to identify all of these things under a microscope and in hand sample, because there's different things you can actually do to identify them. Petrography, which is the using the microscope that I like, is actually one of the things that I did during my master's. Yeah. And scanning electron microscopy. I actually ran an SEM lab for 4 years.
So, when you said it the first time, I thought it was like the study of oil or something. I was like, petroscopy?
Well, actually, petrologists do oftentimes look at sedimentary rocks like oil and things. And
yeah. Because I'm from Texas, that's what I know, right? All the geologists I know are people who are trained to look for oil in Texas. So.
Well, I know a bit about that just because the university I went to was in the San Joaquin Valley, and there's lots of oil there. So we have a big sedimentary department that focuses a lot on that. But I luckily got to look at a process called carbon capture and sequestration, where we were ideally going to pump CO2 as a critical fluid into an old oil reservoir. And one, it's to mitigate greenhouse gas effects, and two, it's an enhanced oil recovery option. Right. But the oil companies, I think the cost-benefit analysis for them, it's not worth.
One of those things, gotcha.
So it's not. I don't think it's going to happen there, but it has happened in other parts of the world.
Gotcha. But we're not out here to look at oil today. We're looking at all sorts of things that are not oil, things that are prettier than oil, I guess, right?
Yes.
So how did you find this place? Are you just like Googling online?
Well, when I do teach about minerals a lot. Right. It's one of the things that I like.
On your Twitch stream?
Yes, I do. And one of the things that I wanted to know is where can I go to these mines and see these, where they come from, rather than, where they don't. And one of the websites I use is mindat.org.
Mindat.
Mindat.
.org. Put it in chat, y'all.
Because, if you just Google a mineral, you're going to get a lot of metaphysical things that come up.
It aligns your chakras or whatever.
And that's not what I do. I study science. So if you want to see the science of these things, mindat.org is your place to go. Scroll all the way down after you Google whatever mineral you like in Mindat. You scroll the way down to the bottom of the page, it'll show you all the locations where that minerals are mined. Gotcha. And that's how I found this place.
So were you looking specifically for a type of mineral, and you
magically I was looking for hiddenite.
Really? Why were you looking for hiddenite?
I don't remember. I have a command in my chat. I think it's just !mineral, where people can use the in currency points that it's just in my chat.
Gotcha.
And ask me about whatever mineral or rock they want, and I think that was one of the ones that was just happened to be picked one time.
Nice.
Yeah.
Yeah, there you go. Jandra got the mindat.org in chat.
It's a good place. It's a good place if you like. I mean, they've got a lot of very, very good data on rocks and minerals. Period.
Right. So if you want like a rabbit hole of rocks, you can go and click on that site.
Yes, it's really, really good.
Cool. So, what else? What else do you do on your Twitch stream? Like,
I play a variety of video games, but lately the new thing that I'm doing is a series on planetary geology.
Ah.
So I'm getting.
Yeah.
No, it's honestly kind of whatever tickles my fancy. Oh, and hydrogeology I got into. I actually co-taught a hydrogeology class at Cal State. And I never understood why he asked me. I mean, it means a lot to me that he asked me, but I'm like, you're the hydrogeologist, why are you asking me? But that was a very, very good experience just because, well, every time I teach something, I learn that much more.
Gotcha.
Gotcha.
Right now.
I'm not gonna lie, I'm obsessing about all of these emeralds and hiddenite here. There are some spectacular specimens, and I'm excited to go digging tomorrow because there are quite a few minerals that are native here that I don't have in my selection or my collection, and I like to use them to teach. Because one of the things I found is a lot of people misidentify minerals because they look for color, which is a terrible, terrible property to identify any minerals ever.
Right.
Because quartz can be purple, it can be clear, it can be that smoky quartz that he pulled out.
Yeah.
It can be yellow, it can be all rose quartz. It can be all sorts of different colors. So
Gotcha.
it's one of the worst ways to identify. So it's one of the reasons why I like to teach about it.
Right.
And you can actually get what's called a Mohs Hardness Kit, which
Right.
is really cheap.
I've seen that before.
On
It's like-
geology.com.
Yeah.
Yeah, it's just a little kit of there are 9 different minerals that they send you, each of a different hardness on the Mohs Hardness Kit,
Gotcha.
which is pretty cool.
And you just like get to scratch them or whatever. Isn't that what you do?
Yeah.
Like you straight up scratch them.
Yeah.
And depending
sometimes
on how
you can scratch them on each other
Yeah.
if you don't know, and you know one of the minerals hardness, but you don't know the other.
you know the other one.
And then that'll enable you to determine that too. We also use hydrochloric acid,
Okay.
and well, it's dilute. It's not just pure hydrochloric
Right.
acid.
It's like cut or whatever the right terminology is, huh?
Because I don't know if they have any of them here. Basically any carbonate, calcite, dolomite, anchorite, siderite, rhodochrosite, will effervesce.
Right.
When you pour it on there.
Bubble.
Yeah.
Like
Just bubbles.
wait, what's the stuff that the Alka-Seltzer or whatever you drop it
Yeah,
and
exactly.
it effervesces, right?
It effervesces just like that.
This is why I know this word.
Yes. And that's one surefire way you're like, oh, got a carbonate.
Right.
It just eliminates all of the other categories of minerals.
Really?
Yep.
And is it easy to tell the difference between effervescing and like just bubbling?
Not really.
Like air bubbles trapped inside it, so I guess not. Really, that's not a thing that
It
happens.
basically just removes the surface.
Right.
It just dissolves away at the surface, just depending on how much you use.
Do you know what gas it's creating when it does that?
Oh, I think
It's like carbon dioxide or something?
Gotta be
Like, I don't know. CO2,
I would
yeah.
imagine.
I don't know. Yeah.
There's lots of calcium and it's CaCO3
Right.
is your main chemical formula for your main carbonate.
Right.
So I would assume it would make. Yeah, I would assume.
I have no clue. Like, I don't know.
I should know.
Wonder Chemist says yes, CO2.
Okay, good.
All right, cool. Well, yes,
Okay.
CO2.
I thought so.
Whew, okay, we guessed correctly. Nice. Again, y'all, if you're wondering what's going on, I'm here too. I can't really reach the camera that way, but I'm here too. This is my representative, and we're waiting for them to finish up with some customers and some people that have come in over here, and then we're gonna go back and we're gonna talk to that guy back there, right, about the rocks and stuff. That's Drew, right?
Yeah.
Okay,
That's
cool.
Drew.
That's what we're sort of standing by.
Drew and Mike are the 2 geologists.
Kind of a dumb question, but why do a lot of mineral names end with "ite"?
I don't know.
It's just what they do. He might know. He doesn't look busy.
It's actually Greek for rock.
It's Greek for rock.
I should have known that.
Is now good? Can we come that way?
Yeah.
All right, cool. Let's mosey over this way
All right.
and see what we've got. All right. So let us know, chat. Let us know if the signal is still good. I did move around a little bit here, and if you want to just run with your rocket, go for it.
So your name is Drew.
Yep.
How long have you been a geologist?
I graduated from UNC Wilmington with a degree in geology in 2014.
Okay.
I instantly came to work here just because it was close to my hometown, and it initially started my interest in rocks. But I never really worked professionally as a geologist, but I was pretty much educating customers here, and eventually moved up to the lapidary pretty quickly to start cutting gems.
How hard is it to learn that skill? How hard is it for you initially?
Well, it's a very specialized skill with specialized equipment. Not only is the equipment expensive, the parts and pieces, for the diamond cutting wheels are expensive to replace.
Oh, of course they are. They're made of diamond.
And so also the rocks and gems that you break can also break your machines. So it's pretty much learning how to make it an exact science for you.
That makes sense.
But Mike Watkins actually trained me in faceting and back and a dome-shaped top. And it's more about capturing the colors and patterns in a gemstone.
Like this one here, is spectacular.
And these are all from all over the world, not just from right here, but primarily it's just to show off a pattern and to make it a calibrated size to put it in jewelry. The faceted gems are the ones you typically see in jewelry stores. They are sparkly gems, and certain gems like Smoky Quartz can be cut into faceted gems or cabochons.
Okay.
And we do both of those cuts here.
Or is there one that's more valuable than the other?
Depends on the stone. On average, your faceted stones are going to be more valuable.
Do these take less time to polish than to cut?
These on average take between 30 and 45 minutes to cut. A faceter will take on average about 2 hours a stone for something that size.
That's actually pretty quick for a tiny little
that's
stone.
like 2 hours?
Right.
Really?
On a good day I can get one of those done in an hour and a half. But it just depends on what kind of inclusions you run into.
Oh, that's really interesting. So I don't know if you guys know this, but a lot of times you can get gas, solids, all sorts of things that are trapped in minerals as they grow.
Right.
So when you hit upon one of these inclusions, what happens? Like if it's a gas pocket or a liquid inclusion or a solid?
Very good question. Solids mostly will stay in place.
Okay.
We were talking about rutilated quartz when you came in.
Yeah, there's a little piece right there.
When you grind over a rutilated quartz, the rutile is actually ductile, meaning it can bend, and the fiber will bend under the cutting lap and then spring back up like a hair, and it'll protrude out of the cut gem until you polish it, and then it smooths it out and stays in place. But if you run into a gas, a lot of times what will happen is a micro explosion.
Oh no!
And all these tiny little fragments of quartz, for example, will scatter across your lap and will scratch the surface that you're cutting on.
And quartz is extremely brittle.
Right, so quartz is one of the most included gems, so you run into those micro explosions a lot of times. They tend to take longer because of the inclusions than harder materials like garnet, sapphire, topaz, and emerald. They all polish better than quartz because they're harder and don't usually have the inclusions, usually have the gas inclusions.
That's so fascinating. I didn't even think about the inclusions when you're cutting and polishing a mineral.
It's with a cabochon, it's not too much of an issue, but for a faceted stone, you want the cleanest, clearest possible end result, and that makes it more sparkly when you all get it done. So
that makes sense.
Inclusions are definitely something that we constantly think about and try to avoid when we're cutting.
I bet. I mean, have you ever cut a diamond with inclusions in it?
I have never cut a diamond.
Okay.
My mentor Mike has cut one diamond before. It took him like 15-20 hours to cut it because you actually have to polish a diamond on diamond.
Yeah.
There's nothing that can speed it up.
No.
So it's a very long process. It's very loud. The diamond creates a lot of heat and noise when it goes across the lap. So it screeches the whole time you're cutting it. When we're cutting gemstones, that screeching process is pretty common on larger stones and on the very top facet, which is called the table.
Okay.
So there's that loud screeching nails on a chalkboard sound for a couple of minutes on a gemstone, but if you can imagine the whole time you're cutting a diamond. I don't really have any interest in cutting diamonds. Colored stones have more light play, and it's sometimes more of a challenge to figure out how to work with the color more than just getting a clear stone.
That makes sense. So then what's your favorite mineral here to cut?
I actually really like Smoky Quartz.
Okay.
It's the most common gemstone we find here.
Okay.
Under the counters, we get we have some examples of crystals that were found along mineral veins here.
Whoa.
And those all came from this property. And when they're not in perfect crystal form like that, they look great as faceted gems.
Okay.
So a lot of times, due to uplift, the mineral veins break and shatter apart, and they're not in perfect condition. So we don't mind cutting crystals when they're banged up already. If it's a perfect mineral sample, I say leave it alone, unless it's really going to improve its value.
How often are prismatic crystals like that found here? Like just
Pretty
nice-
often.
Really?
Pretty often. Not usually that size. But
Well, yeah.
we get
Kind of
prismatic
similar.
crystals from a couple of millimeters tall up to this size, and there's been mineral veins actually where the parking lot is now that the vein stretched 20 feet wide, and the crystals were like over a foot in diameter each.
What does that mean? Like but what is prismatic? Like if you find a prismatic crystal.
So quartz can form in different ways. A
Right.
prismatic crystal form means it has its natural crystal shape, which
Okay.
for quartz is six-sided, for emerald it's six-sided, for pyrite, iron pyrite, they're actually a cubic crystal.
Gotcha.
So that's a prismatic pyrite crystal.
Wow. And that just means like the shape that you see is the same as the like micro shape. I made that word
Exactly.
up, but
It's how it would grow if it given all of the right conditions to form the shape.
in a
that-
vacuum, nothing messing with it,
Yeah,
etc.,
basically.
etc. Right?
The
Because it's cool.
molecules line up in that shape, and then
It's just a
so
bigger
do-
version of the same shape.
Exactly.
Ah, cool. All right. Check. I've
Yeah.
learned something.
Yeah, they have preferential ways they want to form, and there's actually 6 different crystal systems.
Okay.
And it gets very complex and gets into a lot of annoying math.
That's a lot of mineralogy.
That I
Mineralogy,
don't. I
nice.
actually I don't even talk about that part in my stream, mostly because nobody wants to know about it.
It's
Right.
mostly symmetry, and
Yeah.
crystals are the best way to explain that symmetry.
Yeah.
you
That
know.
makes sense.
So
Yeah.
that's when we talk about prismatic crystals.
Okay. Cool. Didn't mean to interrupt. I was just like, I don't know what that means. So.
That
Now,
works.
These ones are from Brazil, right? These
Correct.
big-
Those are Amethyst Geo.
Amethyst is really common in Brazil. Like I've seen gigantic ones taller than me.
Yes, amethyst is actually one of the most common minerals in the world.
Yep.
It's the purple variety of quartz colored by iron,
Yep.
and you can actually find it in all 50 states of the United States.
That makes sense. Quartz is very common.
For scale.
Yes.
Right, quick. There's for scale. That's my phone down there by the amethyst, right? Amethyst.
And those get bigger than that, but yeah, we got some.
Oh yeah. I mean, I've seen ones taller than.
I've seen one that a VW Beetle could drive through. They sliced it on both sides, and
That's fantastic.
so they could drive right through.
Like the redwoods, the one tree.
Right.
that
The redwoods, nice.
they- So what are the most common minerals here in this specific location?
Well, like I said, the Smoky Quartz is the mineral that we follow in veins. There's actually 63 different gems and minerals found at this one location. Smoky Quartz, Amethyst, Rose Quartz, and Citrine, so all the different
Yeah.
quartz varieties. But also Emerald, Aquamarine, Topaz, Garnet, Sapphire, and Hidnite, of course,
Yes.
which is the mineral only
That's a
found
pretty
here
good
in the
piece,
entire
too.
world.
Yeah.
Um,
Can you explain why? Because there are dupes of hiddenite elsewhere. And
Right.
it has to do with chromophores.
right. So Hidnite is a spodumene crystal, which
That
is
is
lithium aluminum
actually
silicate.
fossilized seed
It's colored by
rock.
chromium at this location, and that's the
That's
only
really pretty.
site like this in the world.
You see
The belt occurs
I'm
3
from
miles
very
in
hard
length.
here.
It follows the train tracks out on the main street,
Okay.
and it's a half a
Oh,
mile to
just
the north
a
and
couple of
south
dollars.
of the train tracks. So it's very
Couple of
condensed to
dollars.
this one little area.
That's fantastic.
And it's
more
where
like one or two.
chromium that was in pre-existing rock was cut through by mineral veins, and it picked up the chromium that was in the rock and injected it into the lithium crystals.
So maybe some injection of magmatic activity.
Yes.
Okay, so you have some magma sills and dikes
Mhm.
shooting through, and all that hydrothermal water coming off of it is what carried the ions necessary
Yep.
to alter it.
So there's water mixed in with the magma.
Yeah, that makes
and
sense.
that's what transports minerals. It leaches it from the surrounding rock So it would pick up the lithium, the aluminum,
That's really
lots
cool.
of silica, and
Yeah,
enough
silica's
chromium.
everywhere.
And then it has to enter the right heat and pressure scenario. And that's usually because it gets stopped by something. Like, if you can imagine, the pre-existing rock here kind of looks like a folded rug. The mineral veins will try and break through the easiest way up through those different layers. Sometimes they have to ride horizontally underneath them. Sometimes they'll break and go diagonally.
Path of least resistance.
Exactly. And if it gets hung up underneath a rock for long enough, it can break out a pocket, and it'll mineralize prismatic crystals in that pocket.
Oh yeah, so little geodes.
Exactly.
Diagenetic alteration is a similar thing that happens in sedimentary basins. So basically you get burial of a bunch of sand and stuff in a basin, and you'll get pockets that form because they all rearrange mechanically over time. And then eventually, if you get the right kind of fluid with the right kind of elements in there, you can get a geode. Just like, well, it's a different environment, but that's the environment that I studied, with sedimentary basins.
Sedimentary geodes are some of my favorite, actually.
They're really cool.
Because you get magmatic geodes and then sedimentary geodes. And actually that purple and blue rock up on the counter,
This one here?
yeah, that's actually a agate geode that formed in...
Looks like travertine.
It was in a fossil coral reef. So the silicious ooze at the ocean floor filled in
Crystallized.
the cavities in the coral reef and solidified under heat and pressure.
So
to
there's one of the
make
cavities right there.
Yep, and it has little Drusy Quartz.
Yeah, you
in
can see
those.
that. And Drusy Quartz is just mean the crystals are really, really tiny, such that it looks like snow.
Right.
That's why they call it snow Drusy. Pronounced wrong, right? That's fantastic. So the red and the blue, is that from maybe some iron?
It's from heat.
Actually,
Actually, the Native Americans would, in the like the Georgia area, South Carolina, Georgia, and northern Florida, would use that rock to make their artifacts with, and they would heat treat it, and it would turn red like that.
Oh, how interesting.
So it underwent some type of heating scenario either before it was unearthed, or maybe even Native Americans were baking that rock.
Well, I found that a lot of, for example, Tanzanite, I noticed that you can get what's called pleochroic Tanzanite, and what that means is just when you rotate it, like 90 degrees, for example, it's a different color, or a slightly different color. So you rotate the mineral and you get a different color. You rotate it again, you get the initial color. Rotate it again, you get that secondary color, which is really interesting to me. And then I learned that when it doesn't have that nice blue color or that pleochroic look to it, it'll get heat treated because that'll actually emulate that.
Right.
That
So
pleochroism.
most Tanzanite is dug out of the ground, and
most
it looks
of it is
brown.
actually.
It looks like a smoky quartz almost, and for a long time nobody even wanted it. Once they figured out that they could heat treat it, it became mass marketed, and about every cruise guest that I see come into the mine shows off their Tanzanite, and they say how it's running out, and
it's not.
and it's soon to be gone forever. So if you're on a cruise, save your money, get your jewels from a trusted source, and probably not go broke on your cruise ship.
A trusted source like the Emerald Hollow Mine. No.
Absolutely, that'd be great.
You guys are clearly very knowledgeable about what you're talking about. Like I know quite a bit about all of this, and I mean you're not. You have a wealth of knowledge. That's
we just
great.
immerse ourselves here. It's 7 days a week, 365 days a year.
Yeah.
Like this is what you do. You're out here every day.
Every
Your
day.
job full up like.
I either talk about stones or cut them. That's it.
Cool.
So what's the history of this particular mine? Who founded it?
So Mike in the back, he actually opened this place in 1985 with a couple of partners.
Okay.
And his wife Dottie. They bought out their partners in 1986 and opened the mine to the public in 1987, shortly after they discovered a 1686 carat emerald.
Wait, what?
There was a massive 3/4 pound emerald found on site about 20 yards from where the dig site is. It was found 8 feet deep.
Can we dig there?
I think he found everything in that
You
hole.
found everything in that hole.
He spent 8 days digging down without hitting a single quartz crystal, following a mica trail. So when there's no quartz, mica will still follow where the veins go, and is arguably more important, a more important mineral for prospecting than even the quartz.
How interesting! That's something I didn't know.
So.
Is there a specific type of mica?
Muscovite mica is the most commonly associated with the mineral veins. And on this rock down here at the very base of that example, there's muscovite
these little
books.
Sheet looks like
they're six-sided crystals, but when they line up together, they're called books because they're made of infinite amounts.
Exactly.
Of sheets.
I've done SEM imagery on muscovite and biotite, and it literally just looks like sheets stacked together. It's really, really interesting.
So that's what we study here, or that's what we follow, is the mica and quartz vein. And actually, if you come over here, we have a picture of Dottie, who was also there when it was found. That's the emerald that was found.
That's fantastic.
It was, like I said, 1,686 carats, undamaged, except for a fracture at the bottom. It's terminated, which means it has a full crystal top to it. And it actually had two pieces that attached to it. If they were all intact, they would have been the largest.
Doubly terminated, or?
I'm not sure if it was, but it would have been the largest emerald in North America if it was all intact. But it was gem quality. If you take the photograph out of the frame, you can actually see her thumb through the crystal, showing its clarity. Dark emerald green. It's just museum grade. And they were actually offered $1.5 million the year that they found it.
Wow.
Oh, did they sell it?
They turned it down.
Good for them. I would have done the same thing. I would have kept that thing.
Where do you replace it?
Yeah, exactly.
No.
You can't.
Is this a dioptase?
That's actually the dolomite with a muscovite.
And I'm sorry, you were about to ask.
No. Oh, no. So somebody in chat asked, it was 3/4 of a pound?
Yeah. 1,686 carats.
1,686 carats, 3/4 of a pound, and somebody in chat can do that in kilograms, because I don't know.
Well, a carat is 1/5 of a gram.
Okay.
So a fifth of 1,686.
Divide 1,600 by 300.
Yeah, 350 grams.
Okay.
So,
there you go. I didn't know that. A carat is a fifth of a gram.
Yep.
I don't know that either.
Simple mass measurement.
That's fantastic.
But so that's what got them really, really excited about this property. Once they found that, they figured that education was a better way to market this place, and they opened the whole mine to the public. It actually used to operate more like a commune. People would drive their campers, park here, and they could spend weeks at a time digging for a fee. You pay every day, you keep everything that you find.
Oh, wow.
And customers found emeralds, quartz veins, aquamarines, and
how often is aquamarine found still?
It depends. There's two different types of veins that formed here at different ages. The pegmatite veins are full of feldspar quartz and mica.
Pegmatites.
Aquamarine like those. The emeralds don't like the pegmatites.
Really?
They actually occur more in the hydrothermal veins.
Oh, that's right. You did mention that.
So the hydrothermal veins are more glassy, smoky quartz. This is actually a really good example of a pegmatite. So a pegmatite on the outside will look like big feldspar crystals, and this was a pocket where the smoky quartz was allowed to grow much larger, and there's a little aquamarine hanging out in there.
Do you mind if I
please do.
So for those of you who don't know,
I was zoomed all the way in.
Oh, okay.
Yeah, you can stay right where you are.
So pegmatite, so there's the aquamarine. Pegmatites are basically lava injections that cool so slowly you get bigger crystals that form, which is very different than an extrusive piece of lava like obsidian. It cools so quickly, no crystals have time to form.
And pegmatites are known for large crystals.
Oh yeah.
Not every large crystal in a rock is considered a pegmatite. Only ones that have ideal crystal form. And so these formed in the probably the Triassic during a rifting event. So when the earth rifts open, it allows magma to flow up. Think like the mid-Atlantic ridge. The magma is flowing and creating crust, oceanic crust at the center of the Atlantic Ocean.
And it's still spreading.
But the inside the continents, it might not reach the surface. So you might never get a lava flow, but anytime there's rifting, it's allowing kind of a lower pressure system to where magma starts flowing upward. And so the first intrusion was during the Triassic period, older than 265 million years. The hydrothermal veins were later in the Cretaceous, so right at 65 million years and a little bit past then.
Cool.
So,
That's awesome.
so, but the oldest rocks here are Precambrian in age, which are like 600 million years old plus.
If you go north up to, I'm not sure how far north you need to get, but you actually get the first mountain building event called the Grenville Orogeny, which is about 1.2 billion years old. So the Appalachians in its entirety, that was the first mountain building event out of, I think there's four.
There's four
major mountain building events that creates the entirety of this mountain chain.
Of the eastern
Yes.
mountain belt.
Yes.
And there were two that actually created the most activity in the Blue Ridge Mountains in the southern Appalachians. So you had oceanic rock that was smashed together. It rifted, and that's that first intrusion event, and then another collision, which, if you already have folded and deformed sedimentary rocks, they're going to become very complex metamorphic rocks the second time around. So when you go up to the Blue Ridge and you're looking for rocks in this area, sometimes it's really hard to even tell what they used to be.
Yeah, it gets really messed up. I mapped, because I do geologic mapping as well. I don't know if I said that. I do a lot of everything. And I did some mapping in the southern Sierras, and there's a lot of sedimentary stuff that gets metamorphosed, but a lot of it was only partially metamorphosed, so it's kind of hard to tell between the sediment and the metamorphic stuff, because it's essentially just garbage rock just in the middle, and it was awful to map. But do you guys have any like meta sediment here? Is that kind of a thing, or is it
it's like meta sedimentary,
so it's very, very highly metamorphized?
Right.
Okay.
Yeah, there's no real sedimentary rock until you get back out to the coastal plain.
So what are some of the index metamorphics you might find? Index metamorphic minerals?
Silmonite is actually one of the classic minerals that tells us our heat and pressure scenario.
Kyanite, silmonite, and andalusite.
Right. So there is kyanite in some surrounding areas, and andalusite not too far from here.
This is kyanite.
But the silmonite is a little less gem grade than the kyanite. They don't look as pretty, but they still have that elongated structure to them. And silmonite basically is aluminum oxide silicate. Same with kyanite and andalusite. But depending on the pressure and heat scenario, you'll get one of those three minerals.
So if you find one with silmonite and another with kyanite, then you know that the temperature and pressure regimes were actually different for those two rocks, which is, I think, so cool.
Right.
Just one mineral can tell you a little bit about the heat and temperature conditions and how that rock formed.
And those will form along the garnets and topaz and sapphires in the area.
Is topaz a metamorphic index?
It's not really an index, but you do get it in metamorphic scenarios.
I wasn't sure about that one. Man, I love this stuff.
Did we look at the Hidnite a lot, or
not yet?
That's okay. I'm not trying to.
No,
Hidnite is. We were talking about it a little bit.
Yeah.
It's the lithium mineral. The green color is colored by chromium. These are some small examples. They are usually found very splintery because it has two cleavages where it naturally breaks and shears in a perfect plane. So you get a lot of little box-shaped crystals. Bigger crystals can go for hundreds of thousands of dollars just because they're so easy for them to fall apart. And this is actually a matrix piece where it shows a hidnite on the quartz vein.
Oh, right there, huh?
And it's sitting on the old oceanic rock, the biotite granitic gneiss. A quartz vein cut through that, and it formed actually two hidnites, but the other one's too small. Most people can't even pick it out. But that was a neat crystal matrix piece, because usually you never get the hidnites on matrix. They're always loose in the clay. But I've got two pieces of hidnite over on the counter here that you ought to see. These are more gem-worthy pieces. This one's got a really nice color zoning to it. It goes from dark emerald green to kind of yellowish. And it is very, very thin.
But you can even
and
see
very
on the
fragile.
C-axis how much darker it is.
And we actually cut this mineral when it's thick enough to be faceted. There's no guarantee when we start one. It has 2 cleavages that can always break, so it's very nerve-wracking to cut a piece.
Are the cleavage planes perpendicular to one another?
The cleavage plane is one here and one perpendicular to it here. And Hidnite is actually one of the rare minerals that has 2 hardnesses. It's like kyanite. With the direction of the crystal, it's actually very soft. It's a 4.5 on the hardness scale, so softer than your teeth. Against the grain, it's a 6.5, similar to moonstone. So when you're cutting it, one side, these 2 sides will cut very slowly, and that's what we want.
Yes.
And these sides, the long ones, will cut very quickly, which is kind of dangerous because you can grind too far too quickly.
I had another gemologist tell me he hated polishing kyanite because this weighs, I think, a hardness of 4, and this weighs I think it's 4 and 7.
7 and 5.
Yeah.
And yeah, I've faceted and capped kyanite, and it's a good way to get all that contamination into your lap because they will splinter like crazy. And the next 10 stones you cut will scratch from cutting kyanite.
Yeah, especially from that one hardness of 7.
But this is a faceted hidnite. When it's faceted, hidnite goes for between $2,000 and $3,000 per carat, because not only because it's rarity, but it's difficulty to actually cut.
How much is that?
This one weighs 1.86 carats, and it runs $5,600
Wow.
for the stone.
Wow.
This was cut by Mike. He and I are about the only people crazy enough to cut hidnite. Most people don't even start it because there's a 50-50 chance in an ideal piece that it'll fall apart.
It's so strange to me that this is the only chromium-bearing hiddenite because spodumene is such a common mineral.
Right.
Feldspars are super common. I think that's so unique.
What-
It's all because of the chromium.
And it makes sense because hiddenite and emerald are both colored by chromium. So this area had enough chromium in the host rock that when the veins cut through, they leached enough chromium, and that just doesn't happen. The spodumene and the emeralds don't happen together anywhere else in the world either.
Yeah. That's amazing. I hope that a lot of you adventurers come out this way sometime.
We'd love to have you. We're open 7 days a week, and
This is a fun place.
you keep everything that you find. So
Yeah.
if you find big emeralds, they're yours to keep.
That's like a thing. That's how it works. Whenever you come, you like pay a fee or something, and you get a
Right.
permission to dig or
It's
whatever.
$30 to dig for the day. That allows you to go to our mine, the creek, and use the sluiceways to wash through your dirt. And anything you keep or anything you find is yours. So if you find a big emerald, we're not going to take it from you. We're not going to try to buy it off of you. It's more about you finding it and getting to share your story with
The
everyone.
adventure of doing it.
Right.
That's great.
We'd rather you keep it and tell everybody than us just sell it for what it's worth.
I assume this is a silly question because this is such a rare mineral. I assume there aren't any industrial uses for hiddenite.
Not for hiddenite in particular. It's not abundant enough to process and mine for industrial uses, but spodumene is actually a good lithium source.
Yeah, that's what I've
It's
read.
used in batteries. Pharmaceuticals will use lithium for like
Lithium is-
anti-anxiety medicine.
Yeah.
The drug lithium that's not its only ingredient, but it's generally
I didn't
used
know that.
in all
So it's
anxiety
just called
medicine.
lithium.
Right, it's a
It's
combination
psychotropic.
of
Got it.
elements, but it does have lithium in it. But it's also, let's see, it's primarily for the battery uses and electrical.
But hiddenite itself is just
Hiddenite is pretty much a collector's gem, or used in jewelry.
Okay.
This piece you probably wouldn't want to put it on jewelry; it's just too fragile.
So
But
pretty.
nothing wrong with making a big pendant out of that and showing it off.
Yeah.
That's another thing about hiddenite is it has chromium, so it never fades in color in sunlight. If you take kunzite, trypane, or vanadium-rich spodumene, which are the varieties found at other locations, if you take them out in the sun, they will shortly, within a week, start to leach the color, and it'll bleach to almost white.
And there are other locations that sell green spodumene, but they call it hiddenite, but it's actually colored with the vanadium, not the chromium, which is why it loses its color.
California, Brazil, Afghanistan, Russia, and Madagascar all have green spodumene. But Afghanistan is probably the worst about calling it hiddenite, and they'll even irradiate the crystals with radiation chambers that turn them to a brighter green like these.
And they'll just fade over time.
Right, and they'll fade extremely quickly in sunlight, but they don't have to have sunlight to start fading. But the main thing, if your hiddenites are bigger than this and aren't running thousands of dollars, it's not hiddenite. It's I won't say it's a trick, but it's
it's something else.
It's a substitution. They're not.
Substitution.
So
they're duping you.
So just be careful for online purchases. If it's big, it's probably not from hiddenite. Yeah. If it's very small, there's a good chance. And
do you guys do you sell these online as well?
We do.
Oh, nice.
We have a Facebook Live that sells minerals from here and all over the world as well. We're also starting an online sale department for our lapidary shop, where we'll be selling hiddenites, gems that we've cut, and jewelry that we've cut and mounted here in the shop as well.
That's fantastic.
But you're, just a phone call away if you want to make something custom too.
Yeah, I read that online, that you guys make custom. So do you use multiple metals for that? What's your...
We can mix gold and silver.
Okay, gold and silver. Platinum metal?
We don't really work with platinum or tungsten, or we work with the precious metals that are easily available, more affordable, and easily customizable. So when someone outgrows their ring, you can size up gold, silver very easily. Sizing up platinum and tungsten and those things don't work too well.
It's a lot harder. I do want to ask a couple more questions, because I wonder if a lot of people may not know what these are. What is the sluice way? What is creaking versus the digging?
Sure.
And that's going to be the last thing I want to know.
We use those terms all the time here, and it's really site specific to here. So a sluice way is a device used for speeding up the screening process. So we have a water flume that just continuously runs water from our pond. We pump up water from the creek to our pond. It flows down through the sluiceways where people can wash their dirt off and see what minerals they're digging inside their dirt. It goes into settlement ponds, which filter the sediment out of the water, and then that gets pumped back up to the pond as well. So we keep it a closed system. Nothing enters the stream that could contaminate it, like fish poop, or if kids drop something into it. So it keeps it a closed system. Nothing re-enters the creek. So the sluiceway is designed to speedily get through your dirt. So when you're digging, everything's red clay up there. Yeah. So emeralds are red, hiddenites are red, quartz crystals are red. Everything is red, and you can't see what you're doing really. So it's really important to wash your minerals.
That makes sense.
Get the red clay off, and then you can sort of see what you have.
Now you get the minerals by the digging and the creaking, correct?
Correct. So a digging pass would allow you to dig buckets of dirt from the about 4-acre area. It's about 3/4 of a mile, so it is a little hike to get there. You carry your buckets up, you walk them back, or carry them back on a big wheel wagon. You do need to bring your own tools if you're wanting to speed up your transport. We've got shovels and buckets for rent, but the wagons, the hand trucks are all going to save you a lot of energy getting them back and forth. Yeah. You have unlimited amount of trips back and forth to the dig area or the creek, just not from one to the other. So you can make, if you get into a mineral vein, we encourage you to keep digging it until you can't anymore, or until it disappears, because you might be a foot away from where it pockets and the emeralds show up. So,
good to know.
So you get unlimited trips back and forth to the dig area. If you choose creaking, all you'll use is a plastic trowel and a screen.
So like when they show children how to mine for gold kind of thing?
Kinda. So basically all the sediment from the mine eventually ends up in the creek. There's veins that cut the creek, and when big storms happen, parts of those veins will loosen and erode out into the stream bed itself, and they'll get covered up by sediment. It's your job to get down as deep as you can and screen all that sediment, trying to find the gems that have weathered off.
Okay, that makes sense.
Is that like the best time to come after a big storm?
Yeah.
And it stormed yesterday.
Yeah, it stormed yesterday.
This morning too.
Uh-huh.
So, yeah, so the creek has sort of restacked itself, you know, but really you want to get under a natural deposition area.
Yeah.
A little bend in the creek, the little waterfalls that you see. It's only about knee to ankle deep, so it's not like you need waders, but some people wear them anyways. Rain boots, closed-toed shoes are good ideas.
I just have water shoes.
Sandals are fine, just, you know,
Make sure they're back,
don't get
closed in the back.
your toes pinched in any places. But that's a really nice area for continued screening. You know, you can stay in one place all day, don't move, and you'll have just as much luck as the people jumping place to place,
Gotcha.
if not better.
So if we do the digging, we can't do the screening?
Digging includes going to the creek.
Okay, cool.
You just can't hike from the dig area to the creek. It's
Got
just
it.
a steep slope. There could be,
Got it.
you know, old holes that you might fall in.
Yeah, that makes sense.
We just try to keep it, you know, one or the other, not
And there's
changing
a lot of
back
people that
and
come here
forth.
with their families and little
Right.
ones and things, so you don't want to endanger anyone.
Right. But it is all open pit mining, so there's no big tunnel through the mountainside.
So no spelunking?
No, the open pit mines are pretty much, the rules go, you don't dig deeper than you are wide. Generally you want to be 2 feet deep for every 1 foot, 2 feet
Okay.
wide for every 1 foot deep.
Okay.
And that's just for safety concerns.
Yeah.
People don't realize that the pressure on the ground level will actually push just as much laterally as it does down.
Yeah.
So when you stick your head under a pile of dirt, you know,
Yeah.
you're risking more than what the minerals are worth.
Yeah. Yeah.
That glass.
That does look like bottle glass, unfortunately.
It's like a Mountain Dew.
Unfortunately, but yeah, the creek's been here longer than we have.
Yeah.
So unfortunately, we can't control everything that people get down there. But
Do you get that a lot? Because when we were looking at the Hidnite over there, it was like, oh, that looks like green glass, or the thing that's on telephone poles, or the old insulators. You know what I'm talking about?
I've actually found one piece that I thought was Hidnite, and years later, 2 years later actually, I compared them to some Hidnite that I'd purchased, and I deduced that it was actually glass, not Hidnite. Hidnite has perfect cleavage, so it breaks flat.
Right.
Glass breaks conchoidally like a shovel does.
Gotcha.
So you can't, you know, not everything green out there is an emerald or a Hidnite.
yeah.
How much is
That 75 cents a carat.
Can I just hold
it?
it?
75 cents a carat.
It weighs 6,500 carats.
6,500 carats.
And this was cut by hand in Brazil, not on a machine. So it's just a test of symmetry, patience, consistency, and it's actually just beautiful. It's an inspiration, and whenever I come into work to get to see somebody's work like this, and I do it on a calibrated machine where I'm still designing the angle and the shapes.
Right.
But I've got a stop where it tells me I've reached my desired level, where this guy, he did everything by hand. But
What,
yeah, you
what
can
is
check
that?
out.
What type of...
This is Smoky Citrine. So it's Smoky Quartz and Citrine. Citrine is caused by iron in the quartz. Smoky Quartz is caused by a immense heat, usually radiation underground.
Right.
And when we find Smoky Quartz, you know, it's cutters jump for joy because it's just beautiful when
This is
it's cut.
insanely beautiful. Yeah, you can see that it's like it's kind of in between citrine and smoky quartz, like almost right smack in the middle.
You can see your fingers through it.
I
like on the
know.
camera, it's like it's so clear inside. You can
see my
your
ring and everything.
Yeah.
That's clear.
Oh, you're fine, you're fine.
That's clear. So that's got no inclusions.
Oh, wow. Which is so unusual for any variety of quartz.
It's very rare. So that took a really big crystal to cut a
I don't want to give it back, but I have to.
a completely clean gem like that.
How did y'all come across that? Is that
This was bought at a trade show.
okay?
You know, we go to gem shows, and I highly suggest anybody interested in gemstones to go to a local gem show, whether it's a small one or a large one.
Yeah.
There's just minerals from all over the world, and you'll learn so much. But be careful. Any money that you bring, you will spend.
All of it. Literally all of it.
And since they started taking credit cards there, it's really dangerous.
Dang it, Square. Oh.
Well, thank you very much for answering.
You're very welcome.
I appreciate it.
And yeah, again, my name's Drew, and I'm Midnight Gem Cutter on Instagram. So you know, check out the gems that I cut. Not everyone goes on there, but I try to put the special ones up for people to see and appreciate. So
Cool.
I'd love to see you on there.
I look
Yeah.
forward to following you.
Excellent. What was it again on Instagram?
Midnight Gem Cutter.
Midnight Gem Cutter. Could somebody get a link in chat right quick? Just link that up if you could. I like to boss people around.
I'll have to follow when I have the signal.
Yeah, be prepared to not have any cell phone signal. You're going back to the 80s in here.
Oh,
when
yeah.
You come down to the mine.
Yeah, we're using the Wi-Fi right now to stream chat.
Yeah.
So
Thank you very much.
cool.
You're so welcome.
Excellent.
Glad to
So,
have you.
do we want to step over? He's got customers going on. Do we want to step over and answer some questions or something, or we don't have to stop the stream?
Whatever you want to
Because there
do.
were a
Or
couple
you can
questions.
use the display area.
Cool. All right.
outside?
Yeah. Sounds good. Yeah, one way or the other. And one question on the way out here, somebody asked if they had any uncut gems, so we can step out of the way and let these people go over this way. So I'm just gonna step out of the way here, and then you can like wherever the uncut gems were.
This is all uncut. Well, these have been
Sliced or whatever. I don't know if that's a technical term. But these are the emeralds, right? These are like emeralds uncut
These are the
in the
uncut
rock.
emeralds. I was gonna pick this guy up, but you
Yeah,
can see one of
get
those
the
emeralds
light
right
on it there. Yeah, there you go. So that's an emerald
Yeah.
in there. Jeez. Chad, y'all see that? Do you see sort of the regular crystal six-sided shape right there? That's an emerald with the rest of the rock around it. I don't know what the rest of the rock
It's
is.
some kind
but
of matrix.
Yeah.
Most likely.
that just means a lot of stuff mixed together.
This looks like a lot of biotite. It looks like a schist, so probably a metamorphic rock.
Okay. Cool.
And that would make sense considering this area has been really highly metamorphosed and worked over by 10 million, not literally, but a lot of different orogenies, which means mountain building event, by the way.
Mountain building event, gotcha. And so there's some more back in here, Chad. So this entire shelf is
this
uncut stuff.
all emeralds.
Yeah, look at that. I mean, that you can really see that one right there.
Even this little guy's got some really nice striations on it.
Oh yeah, look at that. God.
And all that sparkly stuff is just metamorphic rock.
Extra.
It's
Extra
just
stuff.
extra.
Look at those right there, y'all. Look, I'm zooming in on that one right there. See that? You can sort of see, you can see the six-sided shape.
Ooh, that's a nice green.
Like you can see that there's 1, 2, 3, 4, 5, 6 sides there. It's so cool. Hey, what does it mean? You said terminated a few times. Is that a word? Was that a word?
That just
Terminated?
means that it actually has its
Like the pointy end?
yeah, the pointy end, where,
pointy end.
or it doesn't necessarily mean pointy, but
Right.
it forms in the way that the crystal shape would normally form. It
Okay.
completes the entire.
It's not broken off on the end.
Yeah, exactly.
Gotcha.
And in some cases, it doesn't have a point. Some cases, this is a flat is terminated.
Okay. But like if it's jagged or something like that, it looks
Yeah.
like it's broken or
If it's
something.
broken, then it's not terminated. You can have
Gotcha.
a single termination or a double terminated.
On either end?
Yeah, so if you
Yeah,
get doubly
gotcha.
terminated, then it would have on both ends.
Because all the crystalline shapes, I don't know if I'm using the right dog. I don't know if you're using the right term, but the crystalline shapes are like one axis. If I say that,
There's actually 3 axes.
Well, there's 3 axes, but they grow like in a line. Does that
Kind
make
of.
sense?
They grow actually kind of more in like, it depends on the crystal shape, but like
Right.
for quartz it kind of goes into like a little circle,
Right.
around and around and around.
Ah.
It's each individual molecule or group of atoms at a time.
Gotcha.
And it gets very complex, and it does depend on the mineral.
Right. I don't know what the right term, but it's like you see the quartz and it's like one big quartz, like a line of quartz, right?
Yeah, but
and
it
it doesn't branch ever.
Sometimes you can
Can
have
it branch?
twins. You can have 2 different quartz crystals growing out of one another. I bet there's,
Right.
I bet there's some.
Can we? Oh yeah, look at all these quartz crystals up here, y'all.
So You can
Look
see
at
a
this.
bunch of little quartz.
Put it over, let's see, we need some light to get on that somewhere. Oh, there you go. Look at that, chat. That's fantastic.
I like rotating it. You can see all the luster. Luster is how the light actually reflects off of the different surfaces.
Yeah.
Which is why multiple points of light are great, because you have so many different surfaces in any mineral.
Yeah. I'm going to see how much I can zoom in on this. There's only so much focus that we can do there. Oh, wow, that's actually really nice. Cool. So there's lots of crystals there, and you can sort of see there's the... Are any of those terminated? Can you tell?
Yeah, so there's a termination, there's a termination, there's a termination, there. A lot of these are terminated. This one isn't. You can see where it's broken.
Yeah, okay. Cool. Yeah, putting it up in the light makes it look really cool. So.
Yeah, it does.
All right.
But sometimes you get...
See what you think about this one.
Oh, wow.
Oh, that's some smoky quartz.
Look at that, y'all.
Obviously, this was one large termination.
Yeah.
But in Hidnite, we get reactivation of the mineral veins, where more heat comes in through hot water, and it'll recrystallize. So all these are actually terminations that recrystallized and grew up again against the crystal. And then at some point, this whole entire crystal broke off of its host, and then it recrystallized.
Oh, wow.
On the other side?
And it double
right
terminated.
Yeah,
So it created its own crystal point on the reverse side where it broke off.
But if she wants to come,
Wow.
Oh, you can see some inclusions in there, too.
Those yellow bands are mud inclusions. So often in Hidnite, when they recrystallize, they'll leave little gaps where they grew over the previous crystal. And ancient mud, probably hundreds of thousands of years old, will inject into the crystal, and it shows up. And you want to leave those in there because that's part of the history of it. You could clean the mud out easily with an ultrasonic, but
it's cool.
you want it in there.
Wait,
like
an
the
ultrasonic,
story.
like a toothbrush?
Or ultrasonic
The
cleaner.
same sort of device?
It's like a bath that vibrates with sound. We use it for cleaning jewelry.
Oh, yeah.
But funny story, one of the locals here dug a giant mud-included Smoky Quartz. They took it up to a university, I won't embarrass them, but they took it up to a university to have it professionally cleaned. When these crystals grow, they get this yellow coating on them from sitting in the iron. It usually takes an acid bath to take that off. You can do it more carefully with like a Q-tip.
Right.
But the university submerged the entire cluster in the acid bath, and it cleaned out all of the mud inclusions. And she was excited about it until she realized that actually made it more rare and valuable.
With all the inclusions.
And so she had a rough time dealing with that decision afterwards. But you know, it's a learning curve. There's always more to know about geology, gem finding, and you know, it's not something you get overnight or in a year. You can come here every day for a year and still be learning.
Right.
Like the Amethyst. It's really pretty.
Yeah, so we're also a rock shop, so we keep gems from all over the world.
Right. And that's what, I think you said the one case behind me over here, the end cabinet is from here, and then everything else is from other stuff, other places, right?
Yeah, that's a really beautiful aquamarine. And it's $700, so it makes sense.
And it's $700, chat. All right, so funding goal.
Donation goal. Holy moly.
Cool.
Turn out the block away. That's some huge kyanite.
Those are actually from Brazil.
Okay.
I like the one that has an X.
Yeah, I do too.
It looks like a Roman numeral 11.
It does.
Oh, it does, yeah.
And
Or the SpaceX logo.
Yeah.
but the really cool thing is that kyanite also forms in North Carolina in the Blue Ridge Mountains up near Black Mountain, just outside of Asheville, and also Balsam Gap, Mount Mitchell, and there are huge gem-grade kyanites in the mountains up there. But a lot of effort has been done to cover those mines up because they're usually at the very tops of the mountains.
Right.
And it's kind of dangerous to get in there. But you mentioned space earlier. The Kyanite Blades found in North Carolina were like up to this size, that blue gem color. And they actually used them on some of the first satellites that went out to space.
Really?
The reflective blue fins on the spacecraft were originally Kyanite Blades, and they replicated
high temperature, high pressure.
exactly. So they would, fight solar rays and things.
That's cool.
In fact, if you play Subnautica, Kyanite was found in the most high pressure, high temperature parts in the game, which actually made me really happy.
That it was correct.
Yes.
What game was that?
Subnautica.
Okay.
And magnetite was there, but I don't think the magnetite was right. These are some Tektites, aren't they?
Right.
Where are they from?
Those are from Libya.
Oh, really? Libyan glass?
And Tektites are splash glass from a meteorite impact. So if a meteorite hits a layer of clay, the clay will bulk melt and turn to a molten silica that's flying through the air. And these were cooled in the air, and so they have the texture of how the air was flowing through and around them. The most gem grade samples of those are from the Czech Republic, and there it's called Moldavite. So you should look into Moldavite samples. Well, they're usually much more green.
Moldavite is specific to that location. Glass is specific to a different location.
Right. Same process in both, both from meteorite impacts.
Exactly.
But what's interesting is the impact for the Moldavite actually was in Turkey, and it splashed all the way to the Czech Republic. So it was a giant meteorite.
No, it hit in Germany from the Rice impact crater. It was the impact crater was in Germany that splashed in the Czech Republic, I believe. I've studied too much on Moldavite. Don't ask why. Moldavite is one of my favorite Tektites because of the green color.
I've got a piece to cut, but I haven't started it yet.
So these are just fantastic. You've got some celestine, some strontium sulfate. That's dogtooth spar calcite?
Yep, from Tennessee.
Oh, there's some amethyst Drusy.
Yep, that's from Argentina. Some topaz crystals.
Oh, those are nice.
I'm trying to keep up with what they're pointing at, Chet.
I'm sorry.
No, you're pointing at lots of stuff, and it takes it a second.
These are actually opalized clam fossils.
Okay.
Wait, what? That's cool.
From Australia.
Opal is an amorphous form of quartz. I don't know if it's an opal A, T, C, or...
I'm not sure, but it's hydrous. That's the main thing, is that it has H2O in its chemical formula, which gives it the refraction of color.
It's a very, very cool... Oh wow, you've got a lot of tiny little opals.
Opal's one of the few birthstones that we don't get at this location. We don't get opal, we don't get pearl or alexandrite.
You don't get alexandrites?
Not right here.
Okay.
And then we don't get the turquoise or zircon that would qualify for December. But other than that, we have every birthstone here in Hiddenite.
Like, you can find it in the ground, you mean?
Yep.
Not like in the rock shop, you have every birthstone.
Every birthstone other than pearl, alexandrite, turquoise, and opal.
Huh.
This basalt with a peridotite.
Yes.
Not only do I want to show that, but I'm actually probably going to buy that.
Really?
Yeah. It's something I want to sample it for a long time. Because it's a piece of the mantle.
That's another one that we don't find here.
Whoa.
Yeah, this is a piece of the mantle, essentially.
There you go.
Yeah,
no, you're good. Yeah.
So
I have a lot of zoom with this camera, so.
So peridotites are found really, really deep in the earth and are exhumed or brought up by various tectonic and volcanic processes, and you might have more information than I do.
This is the basalt, and
that's the crust.
That's what would have it would have been a basalt pipe that came up from the mantle, and it would have ripped off pieces of the mantle and brought it up with it. This is from Arizona, and that's one of the places where the peridotite reaches the Earth's surface and is easily mined. So these aren't necessarily cuttable pieces; they're too grainy.
Right.
But it's from the mantle.
It's from the mantle, chat. It's from the mantle.
This is actually a crystal of olivine peridot. So that's its ideal form
It's so rare to see it.
This one's
like
from
that.
Pakistan, and they actually get crystal peridot, but they also get crystal peridot in Arizona as well on some of the Indian reservations. And
Now, peridot, I hear that a lot with meteorites too. Why do I hear peridot? It doesn't come from meteorites, but it has something to do with it.
I actually don't know. I've not heard of that.
Chat, y'all look that up for me.
Yeah, I'm curious.
I know there's something about it because when I was researching meteorite stuff, that kept coming up. And I think it was something about it was discovered alongside of
Oh, it's a
meteorites.
very basic silicate.
There are olivine deposits in certain meteorites.
Right.
So that's how we sort of know. Meteorites are sort of how we've discovered what's inside the Earth.
Inside the Earth.
We can't dig beneath the crust.
Right.
Also S waves.
Right. So seismology uses basically big hammer trucks that pound the
Boom
Earth,
trucks.
and they measure how quickly or slowly the waves travel through different layers underground. But we also study meteorites that have hit the Earth and look at their composition, and certain ones are iron rich, certain ones are stone rich, and some even have peridot in them. So we know that there are planets or other astral bodies out there that have the same,
Composition is.
composition, and
Yeah.
some that have different ones than us. So it's sort of, geology is cool because you have to look at either really, really small scale
Yep.
or really, really large scale.
Cool.
Well, the other thing about olivine specifically is it's one of the first minerals to crystallize in a body of magma, whereas quartz is actually one of the very last. So this is really stable at high temperature pressure conditions, whereas quartz, where we looked at earlier, is more stable at, surface conditions, generally speaking.
Right, so
And-
quartz crystals can last a long time at the Earth's surface. We'll find ones in farmers' fields out here that are huge crystals that are still perfectly fine.
Right.
But the longer you leave this out in the weather, the more it breaks
It
down.
deteriorates
Yeah.
really quickly.
So out in Arizona, you do have to dig down a little deeper to get the good crystals like that.
Things weather really quickly.
Yeah.
Well, some things are actually, fossils are really well preserved in the desert. Other minerals are not so
Right.
much.
The East Coast is hard to preserve things because it's so humid.
humid and wet.
There's so much soil
Right.
compared to
It's
out
like
west.
biologically active or
Right.
dirt.
I had a bunch of kernite ulexite from a bunch of desert mines that just crumbled. They fell apart here because of the moisture.
Wow.
Just fell apart. Yeah, I'm gonna put this.
All
give
right,
this
I'll
to
hold
you.
this aside for you.
I want that.
You leaving with that?
Oh yeah,
Nice.
I'm leaving with that. It's not. It's a lot less expensive than the fancy minerals, but it's something I've wanted.
That's
for a long
really
time.
cool though.
And it stands up nicely.
It
And it
does.
stands up nicely, yes.
Does it have a little card with it? Like
Yeah.
a little information card? And I'll come back for it when we're done with this. The mantle.
It's the mantle.
It's so excited.
I like it.
There's always a selling point to every mineral. And
Yeah.
Peridot, that's the obvious one.
Nice.
Some people don't like it because it's a kind of a more
It's like
less attractive color of green than like emeralds for some people.
Right.
But
It's the science
cool
for me.
factor, I mean, it's from the mantle.
yeah. Oh, I finally got a piece of eclogite, which is also a really deep occurring rock. It
Yeah.
has garnet in it and peridot, if I remember correctly.
And there's other peridot locations in North Carolina, north of Elkin, and there's some outside of Raleigh as well. So we do have peridot here, but it's usually not in crystal form. It's in a dunite, which is
Yep.
a massive rock with
It's-
very fine-grained crystals.
And it has to have at least 90% olivine in it, or peridot. What is
It's-
the same?
Same thing. And but everyone, I think it's really cool to look at the industrial uses of minerals because everyone thinks of its gem, and they're like, "What do you use peridot for?" They would slice up bricks and line your fireplace with them. They're refractory bricks because no matter how hot you get your chimney, it'll never melt
Yeah.
because it's used to being
1600 degrees.
right below the mantle.
Gotcha.
Yeah.
And back before you had central heat, you would take a refractory brick, set it in your fireplace,
Yep.
close it in a little metal tin, you know,
Case
looked
or
like
whatever.
a skillet,
Box. Yeah.
and you slide it under your bed sheets, and that's what you heated your bed with at night.
Huh.
I actually still have a block of lava where I put it on my wood stove at night and then heat my bed with it.
Really?
Yep.
That's really cool.
Oh,
I'm
cool.
getting this.
Cool.
Have to own up to it.
You're in charge. I'm just running the camera.
Do you want to, did you guys have any questions?
Chat, are there any questions? Now is a good time to, again, I'm holding a phone that has Twitch chat on it right now. If y'all have questions, I'd be happy to forward on some questions.
And then we can check that other area. I don't know if we're going to have to stop stream to check that other area.
We would stop the stream. What did you say it was to walk up to the other area? 3/4?
3/4 of a mile, it's
All right.
not far at all.
We'll just go to the AFK screen, walk up there, then turn it back on, see what happens. Yeah. Cool.
Any questions so far?
Oh,
Good?
it takes a while, yeah.
Oh, yeah,
It usually takes a while.
I'll put my boots on too for walking up there.
Have you collected all the Infinity Stones?
I actually, I'll probably have a post on that on my Instagram pretty soon.
Nice, nice.
So,
What's the most valuable piece at the rock shop?
the most valuable piece at the rock shop. I assume financially valuable, not just.
Okay, what's the most financially valuable, then what do you think is the coolest? How's that sound?
Let's see. Probably that hiddenite that we showed that was already cut.
Right.
It was about 5,600 for the 1.8 carat
Wow.
stone. You know, but we've had emeralds that we've cut here that have sold for $20,000 in jewelry.
Wow.
For like rings and we had, when I first got here, we had a 4.86 carat emerald that Mike cut, and it was the purest green that you could possibly see, as you know, as clear as you could hope for a natural emerald.
Yeah.
And yeah, a Chinese couple ended up buying it on their vacation.
Oh, nice.
So they just saw a $19,000 ring. I think they ended up,
no big
You know.
deal.
I think they ended up haggling it down to 18,000.
Oh, geez, the savings.
So, but historically, I actually really like this matrix hiddenite piece. It's you know, something that you don't see very often.
Right.
Actually, it was a gift. A friend of mine found it in his landscaping. They bought their place and found crystals in the yard work,
Yeah.
and he was like, "Is this hiddenite?" And he gave it to me when he left.
Oh, that's awesome. So that's yours?
Well, it's mine. You know, it's
Yeah,
everybody. You know, it's a museum piece. It's not like I'll never sell it. It's probably worth $2,000.
Wow.
But I'll never sell it
It's
because
beautiful.
you know, there's only probably 10 pieces on Matrix in existence. The largest
On Matrix?
Yeah.
Like with the rest of the stuff
meaning
around it, right?
on the rock.
Yeah,
that it
gotcha.
grew in. The largest was about finger sized, and it was that emerald green, and it was sitting on a bed of mica, rutile.
Oh, isn't this some rutile here?
Mhm.
That looks
Um,
really nice.
And that one I can't even imagine what it would sell for.
Oh, thousands probably. This rutile right there?
Now, rutile is a metallic titanium dioxide mineral. Its common uses are for white paint. It creates the white pigment for white paint. Also, titanium alloys for like tanks and, but also baseball bats, tennis rackets. Titanium has a lot of uses. And for surgical instruments as well. It also reticulates, so if you can see, there's lots of rutile needles
Yes.
coming together.
I'm trying to hold the camera still, y'all. But
That's Maggie and Teddy.
I'm not complaining. I'm just showing
They're
while
our
the camera is like.
but I'll actually show you something really cool about the reticulation, where they group together and they actually spell letters naturally. So you can sort of make out R's and A's. But I'll show you a collection that Mike done.
I remember if this was a variety called sagenite, but I remember there's a mineral that looks very similar to that that's
Yeah.
called sagenite, and I
Nice.
need it just because of, you know,
Just because.
sage.
Yeah.
I can't believe there's just a piece of the mantle here. I'm like,
Yeah,
what?
that's cool. There's just pieces of mantle in this building. Like,
Well, I've always wanted to go to the Himalayas because there's a lot of mantle exposure there.
Yeah.
And there's still collision happening. India's still pushing up north against
right?
the rest of Asia. It's just so cool geologically. The minerals you could find.
Minerals you can find, nice. So Chad, he went off to grab that, and I see there's more questions. I'll ask more questions when he comes back over this way. I'm seeing if there's anything. Do we see anything from Europe in here? I mean, there's stuff from all over.
There's Brazil, which is South America.
Yeah.
There's a lot.
So there's Mexico, Brazil, Arkansas. I'm just reading the labels. I mean, I don't know. South Carolina over there. There's more Mexico, New Mexico, yada yada yada. Yeah, I don't see Europe anywhere, but somebody from Europe was asking if there's anything from Europe. Okay, look at this, y'all.
So this is that mineral rutile, and it's
Oh,
submetallic
wow.
to black. But if you look, we have a full alphabet.
What?
They're a little jostled here, but A to Z. These are, you find lots of I's.
Can I
Yeah,
take a
you find
picture
lots of
this?
eyes.
Yeah, of course.
That's incredible.
That's really cool. So that just naturally came out of
These
the...
are natural crystals. They grow out of one another.
Right?
And they naturally spell letters. And what's neat is this alphabet, as well as two others, were all found in the same pocket.
Really?
That's how plentiful rutile is in the hydrothermal veins.
Well, thank goodness, because I need some in my collection.
It's
So-
straight up A, B, C, D, E, F, G, H.
What's amazing is that capital Q.
Oh, wow.
I mean, how many buckets would you have to do to get a capital Q?
Get a capital Q. Look at that.
You know, obviously L's, T's, V's are pretty common. Y's are very common.
Yeah, yeah.
This one's
but-
really red.
But they'll actually be Jimmy and red.
Yeah.
And that's pretty unique for here. Brazil has some red rutile as well. But that's its pure form, is in its red state.
And then it oxidizes.
And it actually can be clear enough to facet, and it'll look as red as a ruby. And you can see
How
one
long
of
is
the
rutile?
rutile is about a six and a
Oh,
half.
okay, so it's not bad.
It's very brittle, but usually it's too thin or it has hollow tubes that run up it, which prevent you from cutting it. But it's one of the ones that I say if you're looking close enough to find rutile, you're looking close enough to find Himalayite, emerald, whatever else you're going to find.
Oh, I'm gonna find some rutile.
That's
But
cool.
this alphabet, along with two others, were found in the same pocket, and it was right outside of our front steps.
Really?
Is that a dig spot?
Like right there. This is right there.
And the two people that dug it each got a collection, and they sold the third. The third collection sold for $2,600.
Wow.
So about $100 a letter.
No kidding.
And rutile, I've never seen rutile specimens for cheap. Tiny specimens can be rather expensive sometimes. And these are really nice.
It's just cool. I mean, it's just one of my favorite minerals to find here.
The titanium oxide, right?
Yep. Titanium dioxide. And we also get anatase, which is another form of titanium dioxide here. But it usually forms as a white coating on the crystals.
Okay.
Another one that you don't want to clean off. You want to leave that. Just because it's another mineral variety.
Have you heard of sagenite?
Yes.
Is that a variety of rutile?
It is actually a habit of rutile. So,
Because that honestly, when I saw that, it looked a
That's-
lot like sagenite.
so when it reticulates, that's what they'll call sagenite or saginite, and especially when it's held in quartz. So it'll find a crack in the quartz and it'll saginite in the void.
It's so cool looking.
And I've cut some pieces, and it just looks like an alien grid.
Yeah, no,
and
it
it'll be
does.
bright cherry
and
red.
it's extremely
inside.
expensive.
And keep in mind, we charge for the labor it takes to cut
Yeah,
your
yeah,
stones,
yeah, yeah.
Right.
not how valuable they are.
Yeah.
So whether you're cutting quartz or
So do-
aquamarine or emerald, it's all the same price.
Do people bring stones from elsewhere to have you cut?
Yeah,
And
all
you
the
can-
time.
Oh, wow.
Most of the time, people cut what they find here, but I've cut pieces that people have gotten overseas when they're serving the military, ones that people find in their backyard, handed down from their grandparents or great grandparents.
That's awesome.
So we don't care where they come from.
That's awesome.
No.
Good on you guys.
Cool. So there were a couple other questions in there. What is the weirdest rock or mineral you have here?
The weirdest.
What do you think? It's like what do you think about it, Just gonna go dig in a drawer again, chat.
And I gave him $100 a piece for him, and he was really happy.
Here. Yeah,
Chief
go
Red
over this way.
Cloud. We gave him
So,
$100 for his
This is
he-
what we call a copperlite.
4 buckets full.
Oh, it's fossilized poop.
Next year,
And this is its polished side.
Oh, wow.
So,
Oh, whoa.
so it's really pretty. And so this was actually an ancient worm's dung.
Ancient worm
How
dung?
big
Yep.
was that worm?
That's a big worm.
It was during the Cretaceous, so the worms were very large. It
Yeah.
could have been like 20 feet long.
Sure
It was
sounds-
obviously eating well because it's a lot of minerals inside here. And that's what we get the different colors in gemstones from. It's from what trace minerals are inside.
Right, right.
Um,
It almost looks like a biological specimen where they slice it and put it on a slide.
Yeah.
You know what I mean?
Yeah.
and that's all that microscope slides of rocks are.
Yeah.
They just take very fine,
Very thin
sections.
slices.
And you could even analyze it further, but this is another one of those that I probably will never sell.
Yeah.
It's too good of a conversation piece.
Yeah, that's
I'll tell
very
kids
cool.
to touch it, smell it, lick it, and then tell me what they think it is, and then when I tell them, they run out the door.
That's amazing.
That's really cool. That was a good question then. Look. And on one side it literally
So,
looks like a little heap
Pile
of
of
stuff.
dung.
Yeah.
It does.
God, that's really cool. All right, cool. Good question, chat. Good question. It's polished poop. Who said you can't polish poop, right? There you go, right there. There's some
from
polished
Oregon.
poop. That's from
Oregon?
Oregon?
Yep.
Hey,
Really?
And that was
going
about
back to my
a
homeland
35
of polished poop.
Yeah, so you can
That was
polish a
about a
turd.
35
Yeah, no kidding.
40-foot worm.
Give him a 30 or 40 foot worm, chat.
And that was back when the early worm got the bird.
The early worm got the
Literally.
bird.
You got that joke from me.
Nice. So there's another question here. Can you
started
explain
at 85.
or show the cutting and grading process for
Me
gems?
and 3 other
So,
guys were in together.
Grading is looking at a gem and deciding whether it's cutting worthy.
Right.
So basically, we look for clarity. Let me just take a specimen off the shelf.
Okay.
This is aquamarine from Mitchell County, North Carolina.
He's got me working for him.
And when this is a broken crystal, you can see its crystal shape here, here, and here, as well as there, and a little side there. So you can see almost a full 6-sided crystal, but it's been broken.
Thank you for coming.
Because it's broken, I personally wouldn't have a problem cutting this if a person bought the sample and wanted me to.
Right.
If it was perfectly terminated in crystal shape, I probably wouldn't.
Gotcha.
But when we look for cutting grade material, I'm going to go over to our
Sure.
display lights. I look for clarity first off. So you can see a little section between my thumbs where it's pretty clear. In here it's pretty clear. In here, and basically what you start to do once you decide that you're going to cut something, there's natural fractures that you wouldn't want to keep in a cut stone. They just make it more vulnerable to breaking. So you can either saw it, or you can use a hammer and what we call cob it, where you directionally break the sample off, and you put various amounts of cuts to get as many gem sections as you can. Most stones are going to have an inclusion or two.
Right.
Very few are eye clean to flawless. So we're just sort of balancing what makes it more valuable. If it's bigger and has more inclusions, it's going to be better to keep it that way. If it was small and going to have inclusions, but a small clean stone is worth more than a big included stone. So you're sort of balancing all the different numbers in your head. How much is it worth when it's cut flawless? How much is it worth when it's cut included? And then it's just a matter of sawing it in the right places and beginning your cut. When you get down to the gem rough, you would adhere it to a dop, which is usually a brass rod, sometimes a steel nail. You can use super glue or a hot resin wax, similar to when you stamp a envelope. And when it turns solid, it'll hold the stone on your dop. That's fixed to a machine, and then it will cut whatever angles you decide.
Right.
So it doesn't do the cutting itself. You have to manually set the angles and cut to a specific place. And that's for faceting. Now, if I just wanted a large cabochon to show this gem,
Right.
I
These
would-
are the rounded ones, right?
right, like typically Tiger's Eye, Black Onyx
Right.
are done in this form. Those are some pretty common ones. If I was going to do something like this, I'm not worrying about the inclusions. I want size and color. So I would cut the first thing is I would cut that fracture down the middle, and I would make a huge stone out of this side and a huge stone out of that side.
Gotcha.
So 2 different styles of cutting, you know, 2 different people would appreciate them differently. So a lot of times up here, you know, we'll leave it in its raw form, let it sing to the person who wants it, and
Right.
then they can decide what to have it cut into.
Gotcha. Cool. Another good question. Excellent. Here's one. If you want to answer this one, you can. What's the biggest mistake you've made when cutting something? Have you ever been cutting something and you're like, oh? Does that happen a lot?
Yeah, well, most mistakes can be corrected.
Okay.
When you're faceting, each little angle has to be preformed on a aggressive lap, which is usually for us 180 grit.
Okay.
Same as sandpaper. Very aggressive. It leaves lots of scratches. You go over that same cut and all the rest of them with a finer 1200 grit lap. That leaves a frosted look. Then you go over that with a 14,000 grit final polish. And on the 14,000 grit or the 1200 grit, if you make a mistake, it's going to alter the end result, and you have to change every cut that you've made on it.
Right.
So most of them, you can fix the mistakes that you make, but it takes fixing the entire gem, not just that one
Redoing it
little
all
one.
over.
Gotcha.
Or at least making them match. So if you put an extra facet on one corner, you need to at least make the 4 corners all match. What's the worst one I've done? A employee actually found a quartz crystal out in the dig area that was about this big. It had a gem area that was about this big. I had it ready to dop. I'd preformed it, meaning I'd grinded it before putting it on the wheel, before putting it on the dop to an ideal shape that was easier to work with. So I was all ready to go. To melt that wax, you put heat on the stone,
Right.
using a butane torch, and that wicks the moisture off. With a large stone, you need a lot of wax and a lot of heat built up before the wax actually started dripping, and the entire stone just fractured in half.
Oh.
And luckily it was just Smoky Quartz, but it was somebody's.
Yeah.
And also she was very, sympathetic. She wasn't upset.
Yeah.
I've still got both pieces. Both halves still will cut a big gem.
Right.
But it's the difference of getting like a 75 carat stone versus 2 20 carat stones.
Yeah. Gotcha.
So that was pretty upsetting. Never had anything completely go wrong with a customer stone. Occasionally something breaks. You have to change what your approach is. But that was definitely like a blow to
Yeah,
me,
gotcha.
for a day. It actually went up on my story, like I was so excited to
Yeah.
show it.
Oh,
and
no.
then it fractured. I deleted it, pretended it
You
never
deleted
happened.
it?
Till
Never
right now, and
happened.
it surfaced on the internet.
Oh,
again.
wow.
I don't mind. I'm humble.
Nice. Yeah. So here's a question. You're talking about like grits, right?
Mhm.
When you say cut, are you actually
more
like
grinding.
it down?
So-
it's called a cut, but it's not like you're going there with a saw cutting it, right?
We do saw pieces of rock
Right.
to remove excess, but these are cabochon wheels. It's just works just like a metal grinder.
Right.
And then you have increasing grits all the way to 3,000 grit from
Gotcha.
from 100 grit. All this is done by hand or on a nail. So that's just removing the scratches that each wheel leaves. A faceting machine has a different setup. It has a flat rotary lap. The wheel spins, water drips on it. This protractor is what sets the angle,
Right.
and your stone is polished one facet at a time.
Gotcha.
So that's why this sort of takes longer, is because you do each step on a point-by-point basis,
Right.
hoping not to mess up for the entire period.
Gotcha.
So yeah, it's a big misconception about gem cutting. It's not done with chisels usually.
Right.
It
You're not
used
hitting it with
to
a
be.
hammer, like trying to.
It used to be, but now we use all grinding techniques.
Gotcha.
But that's a good question, because I was like you. When I got here to the mine, I was a geologist. I said I'm not a gemologist. Once they're cut, I don't know what they are, and then it just takes practice. I think learning to cut them helps you learn what they are, because you see the before and after so often. And now when I look at rough gemstones, I can visualize what the cut stone is going to look like.
That's cool.
Based on what I see.
That's cool.
So
how long have you been doing it?
I've been cutting for about almost 4 years now.
Okay.
I've been working here for about 4.5, 5 years. But Mike will tell people I work, 300 days a year cutting, where most amateur cutters get 10 stones cut a year.
Right.
Where I get, 10 a day on good days.
Wow.
So it's a little more practice than the average.
Sure, it's like throwing you right in.
Yeah.
Yeah. Immersion.
Do you use anything else, like, to get the actual stones out of a matrix?
Pretty much using hammers to break the matrix off. Like those emerald samples from Brazil, they form in a biotite gneiss or a biotite schist, and the feldspar and the mica, the biotite, will break off pretty easily because there's so many cleavages that you can just strike them in a direction with a hammer and they'll open up. Certain minerals don't like to be, broken off of. That's when we usually use a saw.
Oh, okay. Okay. So do you ever use like a little chisel to get the minerals out other than the saw?
You can definitely use a chisel, especially on big pieces when there's an obvious crack. A chisel will put the break right where you want it.
But a saw is probably your best bet.
A saw is a little more exact. The only bad part about a saw is, like, if we sawed that aquamarine in half, and you left, you wanted to show off your piece that was left over, you wouldn't have the natural look. It has a scoured surface where the saw mark is.
Just like those pieces up above there.
Right, so the saw marks are kind of eyesore versus a natural break. So, that's a little trick.
Yeah, I remember I used to saw sedimentary rock to have thin sections made, and they were never pretty.
Right, until you polish them.
Yeah. Well, yeah, what they do for thin sections is they take what I would do is I'd cut with a rock saw to maybe a piece like, I don't know, twice the size of that pyrite, and then I'd glue it onto a piece of glass, or they do actually, because I send out the bullets, in which we call them bullets. They glue it onto a piece of glass, and then turn it upside down and just grind it just like that with various types of diamond paste of various types of grit.
And they'll grind it to like micrometer width, so that a microscope can see through each of the minerals.
I've actually done it myself, and it's one of the worst things I've ever had to do in grad school.
Jeez.
So you just got the wheel there, and you're just like, oh, I can't do this anymore. And then I've got to put the next diamond paste on there. That's even smaller grit. And the smaller grit you go, the longer you have to do it.
Right.
So it's frustrating.
So as you're in here and you're grinding down different minerals or whatever, is there any hazard to breathing it in?
Both of the machines that we use, the Cabochon wheel has water trays that we use air spitters that spit onto the diamond wheels. That's one to keep dust down, so it turns into mud and it falls back into the tray. But it also keeps the diamonds from heating up. So if a diamond loses its moisture, a diamond grit loses its moisture, it'll start to peel off, and you'll see sparks off the machine or the saw, and you're just losing life of your cutting wheel.
Of the cutting wheel, gotcha.
So there's 2 points to keeping it wet. On the faceting machine, the 180 grit, it's completely covered in water. There's no dust that really comes up. 1200 grit, it's so fine that you're not removing enough to really get it in the air. And the 14,000 grit, we don't use a liquid water, but a very, very high viscosity oil.
A really light oil.
That picks up the diamond grit that we're using, and there's not enough dust to really fly up.
Gotcha.
I'd say, silicosis is the main problem.
That's what somebody asked about.
Yeah, so that would be the main problem, but that's if you're not paying attention to keeping your wheels wet.
Right.
Not wearing a mask if you know that the material is chalky. Most gemstones are very hard and won't turn into dust.
Turn into fine dust that flies around.
You just have to watch out for certain minerals that might be holding like poisonous elements, like copper will a lot of time contain arsenic.
Okay.
So we don't typically cut things like malachite and azurite.
Ah, okay.
You avoid cutting certain gems which are arsenic rich, like
Cinnabar and
Bumblebee Jasper is a really popular gem now. It has these caution orange, caution yellow, caution red colors, and they're really beautiful. They stand out at gem shows.
The reds and oranges and yellows you want to be wary of.
But they're poisonous. They're arsenic. So, a lot of amateur cutters will go buy a piece not knowing what it is, and hopefully you don't start cutting it before you research it a little bit.
Yeah.
Also, on the jewelry bench, there's a lot of metals that fly up, so you just want to wear a mask.
Right.
When you're grinding silver or gold, or you use pumice wheels to do that, and the pumice will fly up in the air. There's a lot of dust in here, but most of that comes through the door more than anything.
Gotcha. Yeah. Off the people that come in, not the.
It's funny.
But that's a really good question.
Yeah.
Something to think about for sure.
So another thing, and I got questions. What's the smallest thing you personally cut? I don't even know if it's a relevant question, but is it
Sure. A lot of people come in with their gem and say, this is probably too small to cut. It might not be too small to cut, it might just be too small to get your value out of it. You're paying me by how much time I think it's going to take. It takes me the same amount of time to cut a 2mm stone as it does a 10mm stone.
Okay.
I've cut 2mm rubies in the cabochons before. I had to glue them to the sharp end of a nail.
Right. Is that what those were up there?
Yeah.
Okay.
And
here, I'm going to see if I can get them right quick. Keep talking.
So these are 11 by 9mm.
Right.
And those are no problem at all to cut.
There we go.
And when they're wet, they'll show what they're going to look like more so when they're polished.
Yeah, there you go. So those are stones already on that nail?
Yep.
Okay.
And these are pretty large sizes. This would fit into the 11 by 9.
Oh, nice, a sizer.
And I've cut ones down to 2mm, which is about the end of that nail before.
Wow.
And we fit 10 of those into the same gold ring. 10 rubies that size
wow.
into the same gold ring.
Wow.
So for them, it's what they wanted. It was worth it.
Sure.
Most of the time, I'll be able to convince you to buy 2mm stones to go in your jewelry as opposed to us cutting them.
Okay. It's just more efficient to buy them than...
Yeah, I can buy 2mm amethyst for $8 a piece,
Gotcha.
or we can cut them for $60 a piece.
Gotcha.
So, I can usually cut most stones, but softer stones you have to worry about shrinking more. So, you just have to balance what the strategy is with each specific item.
Cool.
That we're cutting, but yeah, most people say I probably don't have anything big enough to cut. That's usually never the case. We can always cut something that you find here.
I have a ton of garnet to send to you guys.
All right.
Excellent. Well, I think... Oh, well, here's another one. What is jade made from? Is there any jade here?
I actually could answer that one.
Okay.
Nephrite or jadeite are the two different minerals that go into that.
You know which one is harder?
I think it's jadeite.
Jadeite is a 7 on the hardness scale. Nephrite is a 6 on the hardness scale.
I thought it was a 6.5.
Yeah.
Oh, sometimes.
6.5. Basically, jadeite is usually used for cutting because it's harder and it polishes better. Nephrite will be used for carving because it's softer and you can use Dremel tools to get into nooks and crannies and make. We don't get any jadeite or nephrite here. You could go to California, Alaska,
California has a lot of it.
Guatemala,
Gotcha.
Japan.
Oh yeah.
Actually, there's no jade in the whole region of China.
Okay, wait, what?
The Silk Road is where China got all of its jade from.
Okay. Because that's sort of where I know of jade from.
Right.
From China. It's
Yeah.
like, oh, China, that's jade,
So it
right?
was all traded.
Gotcha. Okay. Cool. Why'd you get started with gem cutting?
Honestly, I was like you. I was like, I like them natural more than I do cut. And then Mike brought me up here on a rainy day, kind of like today, and we had no customers. And he sat me down and said, "You're going to watch me cut this stone start to finish." It was a Smoky Quartz about the size of a quarter, or about, and in about 5 hours he turned it into what's called a Portuguese cut, which has more facets than the traditional round brilliant.
How many cuts are there?
There's only a few traditional shapes, but you can change the pattern on the cut of each of those shapes.
Okay.
But the Portuguese cut has 163 facets.
Oh, whoa.
This is clear quartz. And
So each facet is a side, correct?
right, each
Wow.
flat plane is a facet.
How many did you say?
There's 163.
Yeah, that's good right there when you lean it back a little bit. Look at that.
He did one of these in about 5 hours, and the whole time you're cutting, that resin wax fogs up the entire stone, and you can't see what it's going to look like.
Right.
You can see the cut, but you don't know the color, you don't know the sparkle that it's going to get, and the transformation from the Smoky Quartz, from rough, where it just looked like a kind of gray piece of glass, to a finished cut gem that looked like a disco ball, was the coolest thing I'd ever seen. And from then on, I was like, yeah, I can do this every day.
That's
And,
really cool.
I'm gonna have to look into getting a rock saw and all this stuff.
It's addicting for
So
sure.
what type of
That's
gem is that?
crystal quartz.
That's crystal quartz.
Yeah.
Okay. So we were talking about smoky quartz is the darker stuff a lot, and this is like crystal quartz, which probably means really clear quartz.
Crystal quartz, colorless.
Colorless quartz.
Because you get a lot of milky white.
Yeah.
quartz
Gotcha.
on it.
Gotcha.
And then amethyst and citrine and smoky quartz all have iron in the crystal lattice. But citrine and smoky quartz is this, just slightly heated or irradiated, such that it turns into smoky quartz or citrine.
Right.
But this is just your regular quartz with a little bit of iron. It's just not enough iron. It's a trace amount, so that it's
Right.
not
It's
actually
like
in the
parts
chemical
per
formula.
million.
Yeah.
It takes very,
Yeah,
very
yeah.
little.
So the chemical formula of amethyst and of quartz is both SiO2. And
For example, for a barrel to be considered emerald, it has to contain like 3 parts per million of chromium versus the beryllium, aluminum,
so,
silica.
do they use a SEM or a microprobe to determine the exact amount?
Generally, it's just based on color, but yeah, they could use a spectrometer.
Because I would assume like a lot of the, especially other hiddenite places that think they have hiddenite, you would want to know if they have vanadium versus chromium in
Right.
that to determine that. So I assume that they do zap those, right?
Right, and,
Okay.
and you can send pieces like that and pay GIA to determine the chemical makeup.
I just need to raise $500,000 and get my own SEM.
There you go.
Do it for free.
Nice. What's your favorite cut? You have a favorite?
I'm kind of biased. Mike taught me. He invented a cut called the scissor cut,
Okay.
which
You
is
invented one?
yeah. So he started gem cutting in 1977, and the emerald cut is an octagon shape. It looks like a rectangle from
Right.
the top, and it has flat planes that reflect light just across each other, and so you see stripes
Right.
down it. Problem is, most of the stones that you're doing that cut on have a lot more potential for brilliance. The brilliant cut comes down to a single point, and that throws more light out. So he came up with a way to do a brilliant cut on a rectangular shape and called it the scissor cut. And let me see. This is a emerald that I cut in the scissor cut. And now the emerald generally has too many inclusions to see the cut, so the emerald cut is the preferred. But this emerald is from Ethiopia, which is a new find, about 3 years old, and it has remarkable clarity. So the scissor cut comes to a point and it has an X pattern, and it just throws off more light for any gem that's cut in that way. It also requires a little bit less attention to symmetry because you're coming to a point at the top and you know when to stop, where an emerald cut you have to constantly check each side to make sure they match. So it's kind of like a shortcut, but it produces a better effect.
No pun intended.
There we go.
That's really nice.
Yeah, that's good right there.
So that's a 1.61 carat emerald, and we sell that for $1,200 a carat.
Is that your jar of cut gems?
Yes.
Jar of cut gems, nice.
We've got things like,
That might be easier for me to focus on if it's on the white there,
we've
actually.
got garnet.
Ooh, that's one of my favorites.
That's a huge garnet.
Crosskiller or androdite?
It would be androdite garnet. And that's amethyst.
Yeah, it's a lot easier to get them with on the white background there.
Another amethyst, a little bit darker color.
I love the deep purple amethyst.
The
And
Twitch
this
purple amethyst.
Yeah.
Nice.
And then this is citrine.
That's a really pretty citrine. Did you cut all these yourself?
Mm-hmm. But that's the only scissor cut that I have done right now. I mean, we've got some here for out of the amethyst and rose quartz. But the scissor cut works for almost any gem, so it's one of our favorites. And it did win Tucson Gem and Mineral Show Best Cut of the Year in '79.
That's awesome.
Cool.
So it's award winning.
Yeah,
and
the
it's-
Tucson Mineral Show's no joke.
That's the biggest one in the world.
It is. Get all the wolfenite there.
But I also like, the pear cuts are a lot of fun.
I
Teardrop
just
shapes.
see the garnet.
But emerald cut and round brilliant are the least time to do. So you'll get a cheaper rate on those than any other cut, like the oval, marquee, pear, cushion, trillion. So
I love garnet so much.
have you seen green garnets before?
Yeah, Euborovite.
This is a demantoid garnet.
I have a little bit from Russia. It's a tiny, just barely growth on
Now
top
I'm going
of
to take the
it.
case off so you can see the brilliance.
Wow.
And you'll see dispersion of colors like greens, orange, yellow,
Yeah, I can see
blue.
'em.
And that's the scissor cut that was designed specifically for this stone.
Holy crap.
There it is.
And these go for $900 a carat. You can find cheaper demantoid garnets, but they won't have that kind of color
Oh yeah.
or cut.
That's cool.
Yeah, I've got in my collection of garnets, I've grossular, androdite, and euborovite. I'm obsessed.
And we get rhodolite here as well, which are the
really?
purple variety of garnet.
Oh, that's not a common one.
It's originally named for the rhododendron flower
Oh,
up
okay.
here in the mountains of North Carolina. There's Cowie Valley, which is a ruby mining district of the kind of around Cherokee, Franklin area. And if you want to go mining for rubies up there, the Mason Mountain Mine is actually native dirt from that mine you're digging through.
And they let
Yeah.
you just go in there?
Yeah, you just pay a fee, and their mine is actually just adjacent to the sluiceway, so there's no transport. But be leery of any other mines up in that area. You'll find rubies this big that you can buy at shops that say from India, and they'll tell you every single one of them's from there. And then they'll charge you astronomical amounts to cut them, and then give you a ruby that they already have cut. So
Wow.
to get hand-cut stones, I can't tell you enough. We're doing it right here. Every other place in the Southeast is a swap shop where you get a Brazilian or Indian cut stones, and they're taking your rough and putting it back in their buckets. That's the tourist trap that everybody gets caught up in.
So, do you accept people mailing in
Yeah.
things to cut?
Yeah. If you go to the Emerald Hollow Mine website, it's got instructions on how to send gemstones to us. It's really easy. You can send more than what you know that you want to have cut, and we'll either mail the rest back or just keep it in the package until it's all done.
Oh, wow.
You can always come pick up your gems instead of mailing them.
Okay.
But yeah, that's a great way if you're on the West Coast or just can't find time to come visit. You know, we'd be more than happy to have stones mailed to us.
Good to know.
Yeah, there's a link in chat there too. I mean, we're just like hanging out right now. So, chat is saying that where was it? Let's see here. You have to make sure that you know that this is awesome for you taking the time to do this for us.
Yes.
So the stones are awesome, and you taking the time out of your day. Like, thank you, people in chat. There's 250 people watching, saying thank you for spending your time with us. So
My pleasure.
yeah, we must convey to this guy we were immensely impressed. This is all beautiful. There's one right there. So cool.
Well, this is my job. I do it every day.
Well, you're good at it, clearly.
This is chill and amazing. Yeah, there you go. And there's a link to the website as well. Hey, put his Instagram in there again too, y'all. Like, put the link to the Instagram in there. What was it again?
Hidnite Gem Cutter.
Hidnite Gem. Yeah, there you go. Put a link to that in there.
If you look up Hidnite, you'll probably find me.
because this is Hidnite.
This is Hidnite.
Town of
It's the town of Hidnite, which exists because there's a mineral here called Hidnite.
Yep.
It is Hidnite because it has.
It was first found in the late 1800s
Okay, that's what I thought. I thought it was in the 1800s.
by a mineralogist named William Earl Hidden.
That's right.
Oh, well, there you go.
And he was sent here by Thomas Edison, actually, to find a metal for his light bulb. They thought platinum would be here because of the Smoky Quartz. It wasn't. The Smoky Quartz was caused by a thorium mineral, Moldavite. So there's no platinum here. But he did stumble across the first deposit of emeralds in North America and the first deposit of Hidnite ever.
Yeah.
So they named it after him.
That's fantastic.
Cool.
I didn't know he was sent here by.
No.
Right, that's just enough.
Does anybody else do the scissor cut? Like, have other cutters taken it up, or?
There's a cut called a radiant cut,
Right.
which actually has more facets than the scissor cut, but they go beneath a special angle called the critical angle, and that's the angle at which light passes through the gem instead of refracts back.
Okay.
So even though they do more, it looks worse. They do that on every cut, like in Walmart.
Right.
The fake gems have the radiant cut on them. Diamonds will have the radiant cut.
It depends on the gem that happens to it, because light does pass through different minerals. With different.
Each gem has a different critical angle.
Yeah.
So when you approach a gem, quartz has different angles than topaz, has different angles than
Okay, that makes sense.
diamond or spodumene. And usually the higher the hardness, the lower the critical angle. So a sapphire, has a 9 on the hardness scale, and you can cut it all the way to 34 degrees, where quartz has a hardness of 7, and you have to cut it to 40 degrees. If you go beneath those angles, you've lost the brilliance.
Yeah.
And when you look at Brazilian and Indian cut stones, they go beneath the critical angle, and it's usually to add weight to the gem. They cut it really steep and then really shallow. The bag ends up weighing in more when they've cut 100 stones, and it all sells by the weight. But they sacrifice brilliance for weight.
That's interesting. And I mean, it makes sense because teaching optics and minerals, how it transmits through the mineral versus if it's isotropic, which means no light passes through it, versus if it's refracted at a certain angle. And I didn't know. I mean, it makes sense that you would take that into account.
And certain gems like tourmaline will have down the C-axis, you can have a closed C-axis, which does not allow light to penetrate it, or an open C-axis where you can see clear as day down the crystal.
So some are isotropic and some are not?
Right.
How?
Depends on the purity.
Okay, that makes sense.
And so if you have an isotropic C-axis, meaning or it's closed, it's black when you hold it up to the light, you have to cut it very steep on those long and short angles, or else the dark absence of color will bounce into the stone and it'll darken it. Whereas an open C axis, you can cut it to its correct angles and you get full light dispersion.
I didn't know tourmaline had 2 different varieties. That's interesting. I wonder how that would translate into photography. That must be confusing.
Look it up.
Oh, I plan on it. It's a super interesting, because I do microscope stuff and I don't do gemology. I teach minerals, and this is so fascinating to me to hear just the 2 different worlds colliding for me, and it just makes sense. It all makes sense. Oh, I wanted to ask about corundum, which is what produces your rubies and your sapphires. What is in the sapphire and what is in the ruby that gives it the pink and the blue, respectively?
The blue is usually boron.
Okay.
The red in rubies is usually chromium.
Oh, interesting.
But sapphires aren't just blue. There's all different colors of sapphire, and any color that's not red is a sapphire. Any shade of red is a ruby.
As long as it's corundum and not red, it's a sapphire.
Right.
Okay. That makes sense.
It's one of those lines that humans drew, not the mineral
Arbitrarily.
itself.
Yeah.
Nice. Somebody said Emerald Hollow Mine sounds like a Sonic the Hedgehog stage. Sorry.
Will Jim Carrey be here?
There you go. Oh, this place has been added to the vacation list. That's cool. Jump in string. Could you come here and get a wedding ring cut?
Yes.
Yes.
I saw
We
some-
can actually source diamonds, or we can make it out of an alternative gemstone that you find or that you want us to get for you.
So you could actually come here and you could go work in the stream or whatever and find something and get it cut.
Right.
Like go and find your own wedding ring.
We order the metal through casting companies. It's just more time efficient for us to order jewelry and mount our own gems rather than make our own settings.
So you don't do the metal work yourselves?
Right. We can customize already built settings.
There you go.
Sorry.
We can size them, we can add to them, we can take away from them, but we wouldn't custom build, or we wouldn't cast a piece of jewelry for you. Mike used to, but
Just too much work.
it's
In addition to everything else.
Yeah, it's a
you
whole
guys do.
different ball of wax,
Well,
right?
I was wondering.
we focus on what we got going on right now.
Yeah,
Well,
and that was
thank you
actually
for
a
that.
question that just came up that you just answered out loud, so perfect. Cool. Well, at some point you'll go home, right?
Yeah.
I mean, it's like 5:41 right now, so
We usually stay up until sunset. But
Okay.
I do have to go visit Asheville to see a concert, so I'll be leaving early.
Exciting.
cool. So we should tell chat to say thank you.
Yeah.
Probably, right? Chat.
I appreciate it so much. I've enjoyed it. Nice meeting you two, and
thank you for
the
your
rest of your
time.
crew. And look forward to seeing y'all again tomorrow.
Cool. And we can walk up and check the signal at the other place to see if we should bring the camera back
we'll
tomorrow.
Just touch base with the guys down the hill.
Perfect.
And y'all be good to go.
All right. Good deal. Cool.
All right, let's do it. Let's walk down there.
All right. So chat. It's me again. People are spamming in chat right now saying thank you, Drew. So
I'm gonna come back for
I
that.
appreciate you. Hey, chat. I'm gonna tell you right quick. Whop! I'm still here. Whoa! Let's turn the camera around like that. I've been on the camera today. I'm running the camera here. Rocket Sage is here with me. Rocket Sage in the background. Cool. And then that was Drew, who's one of the gem cutters. How do you say it?
Lapidarist.
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 Lapidarist. One of the lapidarists
Would
here.
you be considered a gemologist as well?
I'm not professionally trained in gemology. You would go to school at GIA. That's the most reputable gemology school in either New York City or Carlsbad, California. And that is specifically the science of cut gems.
Interesting.
So I would say I'm an amateur gemologist, but a professional lapidarist.
Got it.
Cool.
Very cool.
So, y'all, here's the plan. This is what we're going to do. We are going to cut Drew loose here so that he can go over to a concert. And we are going to go to another area. About 3/4 of a mile from here is where they actually look for the gems. Right? All of the stuff that we were talking about there, the hiddenite and emeralds and all that sort of stuff. We are going to go to a Be Right Back screen because I know as soon as I walk away from this building, I'm not going to have any signal. I'm actually streaming on their Wi-Fi right here. But this is partially uphill, and what we're thinking is when we get up to the other area, there may be signal there even though there's not signal here. So if y'all hang tight, how long do you think it takes to walk 3/4 of a mile?
Maybe
Couple minutes, yeah, just hang tight for 10, 15, 20 minutes or something like that, and we are going to walk. I'm going to bring the backpack and everything. I've been wearing the Live View backpack and everything the entire time. Okay, cool. And we're going to walk up there. I'm going to turn the camera back on, and we're going to see if we have signal there. If we have signal there, we'll sort of look around and see how good the signal is. If there's good signal there, we may be back tomorrow, so we may do some actual gem prospecting, rocks and all sorts of stuff out in the field might be the plan, but we don't know if there's signal or not. I know that down in this hole that we're in right now, there are absolutely no signal, so I would not be able to do a stream unless there was the Wi-Fi of the building that we're in right now. Got the live view and everything, got all the modems. I'm gonna hike up the hill and see what the deal is, but again, I'm just gonna switch to the be right back screen right quick, and I mean, like it says on the tin, I'll be right back. That's the plan. So y'all hang tight. Again, if you got more questions, type them into chat, stuff like that. I'll see if I can pick it up when we get on the other side. 4-facet bit, nice. Einsteinway, thanks for the bits there. And that is our plan for right now. Yeah, no, that was fantastic. Everybody, thank y'all so much for saying that again. It's Emerald Hollow Mine. It's in Hiddenite, North Carolina. The place is literally called Hiddenite because that's the mineral that's found here, right? So put the link in chat one more time, and I will be right back. Again, I appreciate y'all. The reason we can do all this is because of your support, so, I mean, thanks, nerds. I'll see y'all in just a bit, though.
In a weight line, so it stays here for 7 months of their weight line right now.
Just 1 second. Hey, Alley Cat, how you doing? Status check. Take this thing off of here. Like that. And flip that back around that way like that. So there should be signal again. Hey, y'all. So we walked all over down in there, right? And there's no place where we can get any sort of real consistent signal. So in terms of streaming actually digging, I think we're out. Even if we could get it to work for like a really short amount of time, I think it would be so much frustration. Yeah. We'd spend half our time worrying about the stream, and then we'd lose a bunch of time to do the digging. So as it turns out, we're not at a streaming location, we're at a digging location. Yeah. So I think what we're going to plan on doing is tomorrow doing some digging and just record it locally. And then we could review footage and stuff like that, probably on Rocket Sage's channel over here. I'm going to see if she wants to use one of the cameras or something like that, like wear an IRL camera or something. I will probably end up back over here tomorrow.
Sweet.
And
awesome.
Come hang out for a little bit. I probably won't be here all day while you're digging and stuff, but it's not that far of a drive for me, so I'm
awesome.
coming up.
That's great.
But I wanted to hop back online and just let y'all know, yes, we should have found a stream. You're right. We're in the woods. If only we had found a stream.
Oh, that would have worked.
Why didn't I think of that? Why didn't y'all think of that? I'm just gonna drop the camera on the ground. just like rub it in the mud, like. Anyways, again, that's why we do this instead of saying, oh, we're gonna go out and we're gonna dig for gems for 2 days, and then we get out here and the signal doesn't work. Today we wanted to test it out and see if there was actually a signal here, to see if it was possible to do a stream. Awesome stream from inside this building right here, right? You can see it actually says that it's the Lapidary. That's the building we were in earlier.
I was mispronouncing it.
How do you pronounce it?
Lapidary.
Lapidary. How do you pronounce it?
Lapidary.
Lapidary.
I kept going all nuts with it.
Lapidications or something.
I think I added a few vowels.
Yeah, but the stream from inside there was fantastic whenever we were talking with Drew, the geologist and the gem cutter. But in terms of going down the hill to where you actually dig for emeralds, it's a no-go on the signal. So I'm going to go ahead and, link up Rocket Sage's Twitch, Gemtown, there you go. Link up Rocket Sage's Twitch, absolutely. Yes. Absolutely do that. And I think for now, I'm just going to go ahead and shut it down. I mean, it's a really nice day.
It's so beautiful.
Oh, it's like air-conditioned temperature outside.
It's really nice.
And the sun's getting ready to go down. They're getting ready to shut down the mine here. But link up Rocket Sage's Twitch there. And there you go. Twitch Rocket Sage. Right there.
Thank you, guys.
Last streaming Bloodborne, apparently.
Yeah, I think it was a mix of educational content and Bloodborne.
And Bloodborne, nice. But for now, y'all, we're going to go ahead and shut the stream down. I'll see what time I get home. I mean, it's Sunday. We'll see what time. It's about an hour-and-a-half drive for me to get back home from here. So y'all are staying up here tomorrow, so y'all going to be over here bright and early, right?
Yeah, I've got a hotel 20 minutes from here.
I probably am not going to be here super bright and early.
Yeah, that's fine.
Just so you know.
We'll be here all day.
Yeah. Okay, cool. So y'all, I appreciate y'all hanging out there, especially as we were sort of testing the signal, not knowing if it was going to work or not. We're able to do the stream now because we came back to the building and reconnected to the Wi-Fi. But the building is like a quarter mile, half mile away from where the dig sites are. But I'm going to go ahead and shut it down now. And I appreciate y'all hanging out, especially people that are sort of waiting to see what the deal was while we came back. I am going to catch you nerds later. And again, Rocket Sage here. Follow her Twitch channel. That's the one we just linked up.
Thanks for being here, guys.
Yeah, of course. As always. I'm just going to shut. I mean, there's no like big outro or anything like that. We'll just see you nerds later.
Bye, guys.